Okay, let's now start the workshop finally, and yeah, welcome once again to the workshop on knowledge-based systems in computational design. This is the workshop at today's workshop at the ICC, ICCC, one of the workshops which is dedicated to some sorts of AI in computational design. And yeah, let me start also the agenda and what you will see today and what you will experience today. So first I will make a short introduction to knowledge-based design for some people who might not be familiar what it is or what the general goal of the workshop is. Then we'll take a look at a very short workshop history to date. After that, we'll have papers presentation as planned, and in the end, we'll have a group discussion. All right, so a short introduction is actually more or less dedicated to the question why and what is this workshop and why we are doing it today. So the general goal of the workshop was when it first started 2 years ago, was to track new directions, new developments, or new applications in knowledge-based design. Back then it was the case-based design, but it grown more and more, and so we decided to extend it more to a knowledge-based design domain. So knowledge-based systems generally and creativity, human creativity, have a long history together. There were different directions throughout the last years. There were different applications or and I would say different domains or different synonyms for knowledge-based design, which was also known as data-driven design or case-based design, or also in the more broader sense, AI-based design. So what generally is knowledge-based design, or what we mean by that? It's a domain for computational design methods that rely heavily on data, mostly on structured data, for example, in the form of past experiences, rules, graph, or statistics, or something that you can also, I don't know, interpret as a human as data. For example, you can interpret an experience, you can recognize what a rule is, what a graph is, and more or less everything that can be interpreted as knowledge by you and by the system is yeah, is considered knowledge in knowledge-based design. And of course, we're speaking here about the design system, so not every system that somehow I know is based on database of designs can probably not be considered as knowledge-based design. So there are some tasks that we consider as classic tasks of knowledge-based design systems. For example, generation of new design knowledge based on previously collected data. Then there's a very wide domain of support and learning of the design process. For example, I don't know, I would say the very interesting application right now is the support of the design process by suggesting the next design step, or by recommending the next design solution, or show how the design can develop using the style of the designer, for example. Also, there is a design optimization, evolution, configuration, and interpretation domain, from which we will see some talks today. Also, explainability of system decisions, of the design system decision is one of the domains of knowledge-based design. For example, explainable AI became very popular in the last years, and we also had papers on that on the previous workshops. We had papers on how the system explains the design and how the system explains the interaction between the user and the system itself. So this can be, this will be put under the head of the explainable AI, or explainable AI and knowledge-based systems together. And a small application domain is all the cognitive architectures for design tasks. Also, probably best known from the game design industry, but it also can be used for example, for other domains. I know some applications or some papers about cognitive architectures for architectural design, and yeah, so this domain became one of the knowledge-based design domains as well. So the short history of the workshop. This is the third iteration of the workshop. It's first time as a ICCC. I believe this is the correct pronunciation of the conference. So we had the first iteration at ICCBR back then in Stockholm. It was more oriented at case-based design research, as I mentioned. The workshop basically started as case-based design workshop, but then was extended more and more to other domains. So in the first iteration, we have the very narrow horizon of case-based design research, basically because it was it was held during the ICCBR. The next year, it was extended to explainable AI because at the ICCBR last year, we had an explainable AI as a kind of conference topic. So we decided to combine two topics together, and we had interesting papers on that too. And yeah, this year we have a very wide application and research domains. So we have very wide, wide, I would say, interval of the domains that we accepted, and I hope it will be a very nice workshop today. Let me share some data and statistics of the of this year's workshop with you. We have 7 papers submitted, and 6 of them were accepted. Below you can also see the organizing committee. So yeah, what's next? The one very important thing that I would like to discuss with you first, or inform you about first, is the proceedings. The proceedings are planned to be published. So some of you already asked about this, and yeah, we plan to publish them together with other workshops. So it's planned as a joint workshop proceedings of ICCC, and this will be published, or hopefully it will be published with CRWS. It's a very renowned, very relevant publisher for workshop proceedings. I published some work there in the past, and usually they have no problems in accepting of workshop proceedings. We need to consider some requirements, for example, a copyright note in the paper, and also for every paper we will need a publication consent, which will be non-exclusive, which means copyright will remain with the authors, but you will grant publishing right to the publisher, to the CRWS. I will inform you about this in the following days. As soon as I have more information myself. So currently this is the only information I can give you, but so just so that you know that we are planning to publish it, we are planning to publish it. Yeah. All right, so let's move straight ahead to the paper presentation of today's workshop. We have two sessions, as you may already know, and we considered every request for presentation time, so we try to do or to schedule that in the best way possible for every speaker. So yeah, let's see how it works. And the first presentation of today's workshop is Marinos Koutsomichalis from the University of Cyprus, and he will present today a hyperstitional machine appropriating human culture in evolutionary fashion. So I'm stop sharing my screen now, and
Victor,
yeah,
I still have a question if you allow me.
yeah.
So about the publication of the proceedings, what kind of term do you expect? Do you expect like days, weeks, months? Just like ballpark.
You mean a deadline for submission of?
Well, on what kind of time scale do you think they will be published?
Oh, this is probably the information I'm not able to share right now because I have no idea.
Okay, yeah, I'll wait for it then.
Okay, as soon as I have more information. So currently we are applying for the publication, or actually the application itself is not really required. We just need to submit the volume where all papers are zipped in archive, and if they find it let's say worthy of publishing, then they will publish it. If they will have some problems, I think they will inform us, and I will also inform you, and yeah, that's the current state.
Okay, thanks.
We can speak about the deadline when you will be asked to provide the final version. For me, it actually I would say doesn't matter. We can agree on one. Maybe it's maybe afterwards during the discussion. So,
sounds good.
Okay. So yeah, Marinos, are you ready to present?
I think I am. So I guess I have to share my screen now. Just let me.
Yeah.
Post disable attendee screen sharing. So you probably have to.
Oh.
To enable it somewhere.
Try now.
Yes.
Thanks, João.
No problem.
Could be. Just give me a moment. Okay. I am afraid that I will have to quit and start again because Zoom didn't have the application. So please give me a moment.
Yeah.
Great. So you should be able to see this now.
Yeah.
Right. Okay. So hi all. I'll try to be quite brief and focus on the most important parts because this is kind of a massive system that I'm about to present. And I'll leave some space for questions later on. So this is about this project that I called Hyperstition Bot. It is about a hardware machine that I have designed and implemented. And it fables about the idea of non-human creativity. So essentially what I try to do is to arrive at a system that unattendedly generates new kind of multimedia content, employing, it works in a modular fashion, so there are a number of synthesizers that it relies upon. But all those systems do not try to imitate human creativity, they rather try to appropriate it. They kind of build upon existing human culture. By human culture here, I mean the way human culture is represented in the World Wide Web. So they kind of draw upon the footprint we humans leave on the internet, and it tries to appropriate it to generate new kind of content in an evolutionary fashion. It draws on this notion of hyperstition. For those of you who are not familiar with this, it comes directly from the work of philosopher Nick Land. I have two definitions here. First is that hyperstition is about narratives that are able to effectuate their own reality through feedback loops. And in this way, they generate new kinds of socio-political attractors. The second is a more straightforward definition. according to which hyperstition concerns ideas that may function causally to bring about their own reality. In this way, they transmute fictions into truth. So this is, let's say, the inspiration of the project. The idea that we can draw upon existing cultural content and unfold it, follow the feedback loops that they may be latent in there, and try to have it bring about its own reality, irrespective of any human agency. The way that this is implemented, because of course this is a very experimental endeavor, I don't say that this is exactly what the machine does, I just say that this is what the machine tries to do. So here you can see some pictures of the actual hardware. I won't get into talking why I have selected these particular materials, why I use concrete and steel, and I have went through this kind of design, which is obviously rather user unfriendly and quite rough-hewn. For those who are interested, I can provide in Slack a link to another paper that I recently presented, where I talk about this particular approach into designing instrument, both in this and in a number of other occasions, because this is something I lately do in a number of projects of mine. Here I just focus on what the machine does. So essentially, this is a very complex ecosystemic evolutionary pipeline. It is distributed in a number of software elements and a number of hardware elements. Internally, it comprises 4 microcomputers and a number of other supporting hardware modules. There are also a number of auxiliary software systems to make sure, for instance, that the files are distributed between the various hardware parts. And there are a number of software components that I will explain in detail in the subsequent slides. So the idea is that this machine may be plugged into the World Wide Web. It retrieves audio content. There is a database system that makes sure that this content is ever renovated, following knowledge graphs and following the kind of links that already exist in the content there. This is the hyperstitional element. And it synthesizes this new kind of content, which can be projected in a physical space by means of a series of outputs. The current incarnation of the machine features audio outputs, 3 distinct video outputs, and there are also some USB interfaces that you can use to download content to a USB device or something like that. And there is also a thermal printer that I use to print text. The core component of this system is this database management system. I have a link to the paper here, Evolvable Media Repositories. I have a few slides briefly examining the system because it's quite a core component of everything. But if you're interested in this in more detail, you can look at this paper. So essentially, in a nutshell, this is the figure that you see exemplifies the process. There is a genomic space which comprises undirected graphs of natural language tokens. It's important to note that natural language here stands for any kind of natural language, as long as it can be represented using the Unicode character set. So essentially, I started with a seed, which typically is just 1 word or a small phrase. And after a few iterations, it might end up with different kind of with tokens in a number of different languages. It actually happens quite often in practice. It's granted that it will happen. So in this sense, the machine already is embedded with the mechanism to explore human culture, the way it's represented in the internet in a trans-geographical and trans-cultural way. So starting with the seed and the first genomic population, there are a number of crawlers. These are modularly attached to the system. They use these tokens as web curators to download content from a number of repositories like YouTube, SoundCloud, Wikipedia, and so on. So they download video, images, text, tags, all kinds of things. These are understood. These are then passed to a series of comprehenders. The comprehenders analyze this material. They analyze the actual material in some cases. There is, for example, an image comprehender that tries to figure out what particular objects lie in an image. But most importantly, there is a natural language comprehender. This is the central comprehending unit, which analyzes all associated text that is embedded with some kind of content. So in the case, for example, of YouTube, it will analyze descriptions. It will also analyze user comments. It will analyze all kinds of metadata that are associated with a video. In this way, it tries to unfold the various semantic links that this particular media token could have with others. And the result of this series of comprehenders is a new genomic population, which will rapidly expand. The phenotype, of course, is the media files that are downloaded and then renovated at every cycle. Here is an example of a graph. This is just after one iteration. The seed here was the word nirvana. These slides are from the original paper discussing the system. So starting with the word nirvana, after one iteration, you can already see that there is at least one token in a different language. So following graphs like this, content is downloaded. I have just to give you a few examples of the kind of content which is downloaded and to demonstrate that this is indeed somehow related with another. I have no idea why the word nirvana ends up with lots of pictures of trains. Again, we have trains and related video tokens. And this is the way that with the addition of a few synthesizer modules, you can see the entire pipeline. This is a version of an evolvable media repository system, which is, of course, customized to fit the purpose of Hyperstition bot, plus the synthesizers that are responsible for generating new kind of content. So starting with the genotype, there are a series of crawlers that are attached there. Just a quick note that the genotypic space is iterated in an intelligent fashion. This is explained in some detail in the paper, so that the hierarchies that are there are respected. The idea is that we should always download something as long as it's possible, but we always start with these web queries that are most related according to what the comprehenders understand in the previous genomic population. So there are a series of crawlers designed to download content from various repositories. The resulted content is distributed among the hardware components that comprise the Hyperstition bot, the system, and they synthesize multimedia content in a number of algorithmic fashions, while the comprehenders analyze this content and they produce new kinds of graphs that comprise the genotype of the next population, and the cycle goes on. As far as the synthesizers are concerned, as of now, there are 4 synthesizers. 2 are fully functional and well tested in real life settings. The other 2 are also functional, but they are still experimental and they are not, they do not appear in the public installation, the first installation where Hyperstition bot has been presented. Some of these modules are based, most of the synthesizers are based in prior research. The text synthesizer is based on this paper, so that it uses recurrent neural networks. Essentially, the network is trained on the kind of text token that are downloaded at each cycle, and then it's asked to generate new kind of text. The audio synthesizer is based on this paper, which is prior work of mine. Of course, this is a very, there are lots of things that are different from the original paper, but this is again an experimental synthesizer, so it is meant to work in a different fashion. Here, it's a 3-channel audio synthesizer, the one that I use in Hyperstition bot, although this is still experimental, so there are no samples to demonstrate at this point, but it's just a tweaked version of this system. There is also a 3D model synthesizer, which is based on this paper, which is a system that is meant to generate objects out of text. Essentially, the final synthesis pipeline of this system is the one that is planned to be used in Hyperstition bot. And I have here, come on. So on the right, you can see these are the simplest synthesizers. It's quite possible to have some algorithmic descriptions. The video synthesizer is a very straightforward one. It just essentially fragments the video content the available videos in small fragments, and then it selects stochastic operations to mass them up, to reassemble them in a different fashion. So essentially, it will play back fragments of the videos that are available and keep doing that as long as there is new material there. So when new videos arrive, it will keep fragmenting them, get rid of some of the old, and continue in this fashion. The 3D model synthesizer is also quite straightforward. It downloads, it takes the available 3D models, performs some random rotations, translations, and other manipulations on the models, and then merges them all and synthesizes a new object. I have a few photos of how an installation of the system looks like. This is from a Children of Prometheus public installation, group installation, which has been curated by Mark Garrett of Furtherfield in London. But the installation took place in Cyprus in Limassol. So in this particular version, its Hyperstitional board outputs 3 distinct videos, plus some text output. There is no audio here for reasons that relate with the overall, with accommodating space. It was not possible to have audio in this particular setting. And I didn't want to use headphones because it kind of contradicts what I'm trying to achieve. This is just a sample of the kind of text it generates. And I also have some examples of the kind of objects the 3D model synthesizer is expected to create. This comes from the original paper, but this is more or less the synthesis pipeline. So these are the kind of models. The kind of models look like this. They are synthesis of individuals models that have been downloaded from Thingiverse. So a few notes on this is that given the particular way the graphs are presented, it is possible, and the whole architecture of the system, it doesn't use any fitness functions or evaluation schemata, so it's essentially free to explore and to maneuver the World Wide Web following merely the links and the semantic relationships that are embedded on the content itself. So in this sense, it is free to explore human culture in its contingency, in its diversity. And of course, this is massively helped by the fact that the system will understand, will operate in a number of different languages. Hyperstitional mode is not meant to imitate human creativity. It is rather intended as a way to enact a new take, a new computational and non-human take on multimedia synthesis. Of course, I don't argue that this is entirely as if. This is a very big question. This is something that we are currently, lots of artists and academics are working in this direction. I'm just saying that this is the goal, this is the intention, and this is a kind of involved example in this direction. It's an experimental endeavor that attempts to celebrate a purely computational and non-human take on how we can arrive at multimedia content which is synthesized without having human notions of creativity in mind. Some critical reflection on the process itself. I will just mention a few things here because these are kind of very open and broad questions. They can't be answered at this moment. I explain a bit more on the paper, but just to say that the way that I understand it, and if seen through a critical post-humanism lens, human creatures are necessarily prosthetic. They necessarily trust technology of various kinds of, in various fashions to, so that we are humans exactly because we trust technology in doing things on our behalf. So seen through these lenses, I think it's a very natural thing to create machines of sort that they try to repurpose their own culture by their own intrinsic computational orderings. And in this, following this line of argumentation, this train of thought one step further, I think that experiments of sorts, they can help us formulate a better and more critical understanding of what creativity, what human creativity is, and how to understand our own species. Well, this ontogenesis and ecosystemic conditions is quite of a more complicated issue, but just to try to abstract it, the idea of hyperstition in the very first place originates in a certain train of thought that comes with Dawkins, you know, and the whole idea of memes and how that memes, that there is a genetic dimension, that a certain idea and certain memes can create crossovers with other memes and spawn new kinds of artifacts or new kinds of ideas this way. This is a very, this is the idea of ontogenesis, that you can have like DNA-like structures that will interact with one another and bring forth almost automatically new generations. There are certain academics from various disciplines that are quite, that they oppose such a view. There is a debate on such things, and the other side argues that this is only possible because it presupposes an environment which is suitable for this ontogenetic process to take place. So essentially what they say is that there have to be the proper environmental conditions for that kind of processes, so that in the end of the day, we can't really attribute the result to the ontogenetic process, but we should rather focus on the environment and the ecosystemic conditions that, that allow it to happen. Hyperstition board has been designed with having this debate in mind, and it's also a way to explore it. It is a machine that it's designed to follow and to implement the unfolding of certain congenital bearings. So it tries to, it's meant to operate in a hyperstitional fashion so that it focuses on the kind of latent links, semantic links and correlations that may exist between particular media, and tries to have them unfold in an ontogenetic fashion so that they spawn new realities according to the hyperstition paradigm, so that they spawn anyway new things following this kind of ontogenetic process. But on the very same time, it's a machine that explores and investigates the conditions that allows this process to take place. And this is probably why I have selected a fully distributed design. There are two different levels of environment in there. The first and most important probably is the World Wide Web on its own shape. Hyperstition board is meant to explore all the infrastructures of the repositories it relies upon, the particular ways one is allowed to comment on YouTube, the APIs that are involved in downloading the content and so on, so that this ontogenetic process necessarily relies on all these complex infrastructures that are bound in the internet. But there is also a local infrastructure that has to do with the particular evolutionary pipeline, with the software modules in question, the specifics of the various crawlers, the specifics of the comprehenders. So there is also a local infrastructure which is meant to enable ontogenetic processes, but it can be argued that it's transparent or neutral in any case, because they also bear the marks of a very ecosystemic paradigm. They are distributed. They don't follow strict rules. They are rather meant to enable and fuel an emergent and contingent behavior. So I believe this is a very interesting question that can't be answered at the moment. And I plan to go on in this direction and conduct further experiments and try to see how exactly this debate can be turned into a condition for creativity, can be turned into a way to arrive at new kinds of original artifacts, multimedia artifacts and processes that synthesize content of sorts. I think I am done insofar as the presentation is concerned. I'll stop sharing the screen. I guess that there might be questions for me.
All right, so thanks, Marinos, for a very nice talk. Very interesting. So do we have questions for Marinos?
guess I have a related work comment.
Which I was going to put in the chat, but I don't know if my audio is doing so good because I'm connecting through my phone. I'll just put this in as a comment. So there it is. I found a couple of related papers that may be interesting to you. They were very interesting to me in terms of the aesthetic. The first one was talking about how computational systems don't have to, play by the same rules of humans, that they can make works which are not even meant to be consumed by humans. And you were presenting your stuff in a gallery setting and talking about how humans are quite interested in looking at them. I don't have a ruling about which view is better or more appropriate. My other comment is about the other paper. You said that your system doesn't have a fitness function in it, but you did say it was evolutionary. So I was a little confused about how that works. Just to comment on this other system has a population of critics as well as a population of producers. And so the population of critics will score and rate the produced artifacts. So humans are indeed basically out of the loop at this point, and the critics are just, judging works, and this causes an evolution of the overall fitness function. So I guess that is a comment leading to a question, which is, you mentioned it's evolutionary, but then you also mentioned there's no specific fitness function. So maybe you could say a little bit more about how that works, or maybe I missed what you did already say about it.
Thank you. These are two very interesting comments. I'll start by the second, and it's interesting because it's time I present a system that doesn't deploy fitness functions. We'll come back to this question. Yeah, apparently there are a few cases of systems that are evolutionary in the sense that they follow the evolution of generations. They are rather based on mutating content. There are a few different approaches to how to arrive at evolutionary systems that do not involve fitness functions and evaluation schemata. I have a few references in other works in the paper. I can, like a few examples that come in mind is that there is a system for audio composition by Bills, which is well-known, GenJam, that doesn't use fitness functions. There are several other systems that they use the so-called endogenous fitness functions, which endogenous means in this context that even though the systems do use fitness functions, these fitness functions, they don't really relate with the outcome. They, for example, there are these systems where you have a robot and it tries to create a design, but the fitness functions doesn't judge the overall design. It's meant to judge a particular line. So the eventual outcome is still evolutionary, and even though there are fitness functions, their role is largely undermined. And there are, of course, this whole new breed of systems that they fell under the category of ecosystemic evolutionary systems, that they're rather based on the complex interactions between different modules, so that any possible the evolution is kind of implicit. It emerges out of the way that the various module interacts. It's a very interesting question. I just don't talk a lot about it because this is in the paper, and it's better to see with respect to other kinds of papers in the field and research work. But my point, and I guess it's kind of a view really, is that whenever we are talking about creativity and art, it's still debatable and questionable to what extent the idea of fitness functions, in the traditional view of computer science, are of any help or not. There is an increasing number of practitioners that experiment with different approaches simply because it's very, very difficult to define what fitness is. It is very easy to do when, for example, you design a system that tries to imitate the words of Johann Sebastian Bach or jazz music or something like that. Even though, by the way, the GenJam that tries to create jazz melodies doesn't use fitness functions. But anyway, still, when you try to imitate human creativity, sometimes you can indeed, actually, when you try to imitate the style of human creativity, it is possible to define meaningful fitness functions. But when you try to do a project like this, it's largely impossible. So you either result in a fully ecosystemic system, which is what I did, or you try to focus on endogenous fitness functions and evaluation, which is a very interesting route taken by several researchers. And there is, of course, the solution to involve human critics in the process, which also has its merits in certain applications. Now, insofar as the other question is concerned, yeah, I agree. It's actually, I find it very interesting and very intriguing, and thank you for the comment. I find it very, very intriguing, the idea of non-human creativity, which is meant for non-humans. I find it very intriguing, and it's something that I really want to engage with at some point, but it's, in a philosophical level, it's very hard to even start reasoning about it. One extension that I have for Hyperstition bot, I mean, insofar as this particular word is concerned, there are two things to comment. One is that I have in mind a few extensions that kind of are some first excursions into this domain. I plan to also introduce a new class of modules, which I call uploaders. So the idea is that instead of merely projecting this material in a physical space, the bot will also upload material in YouTube. It will also tweet things in Twitter. It will also publish on its own, you know, computer-generated text. And this is very interesting because I believe that it will also open up the way to transcend human scale, so that it could maybe upload video, you know, of in YouTube in durations and in frequency that it's impossible for humans to follow. So I do want to get into this thing. The other is that it's quite, I mean, it may not be explicit the way that I present the word, but it is explicit for me that the output of the machine, it's not there for humans to judge. It's not meant to be an aesthetic creation that should be original or nice or anything like that. It's merely meant for humans to witness. So I present it in a physical context, not in hope that that the result is something interesting for humans to appreciate. It's merely kind of trying to give physical space to this bot, to give the opportunity to also present its own outputs to humans, so that humans can witness, but not appreciate or judge or position themselves aesthetically around it. It's very difficult to talk about these things, you know, in a proper academic context, especially, you know, in sub-disciplines of computer science and all this. And to be honest, I don't know the right way to do it, because it's very philosophical, it's very metaphysical, you know, people sometimes complain that it doesn't make any sense at all. I still believe that it's very interesting to get into this thing and try to find the proper language to talk about that kind of affairs. And I guess that the way that I do that kind of installations is that it's my own way to try come up with this language. This language can't be purely textual or philosophical, because this is the language we humans use. So I want to come up with a new language which is partly computational, addressing humans, but not relying on their opinion or something like that. So this is why I go on for physical installations. Yeah.
Interesting answer, much better answer than my question, so I appreciate that. You certainly improved.
No, but it's your question that brought it forth, so I think that your questions were very to the point.
Okay,
so thank you for that.
Cheers, thank you.
All right, more questions, please. So, do you have some?
Hi, Marinos. One thing for me is it is very interesting system, and but do not use any restriction on the system. And you have not a fitness, but I don't understand how the behavior of the system. How can you affirm that the behavior of the system is diverse if you evaluate the system in anything? And if the system consider if the system outputs are artworks, but are you testing with users or with other machines to affirm that they are artworks and the results are diverse, or it's only by your opinion I think this is a very interesting system, and anything else, it's only a...
No, I think I understand the question, and I'd say that neither of the two. No, I don't say that this is artwork just because I think it's artwork. And no, I don't judge the result using human critics or people or anything, because the whole point in a system like this, and I guess if we're talking about art, it falls under the very broad category of totally experimental, exploratory, unclassified kind of art. It's very experimental. So yeah, the results are not guaranteed that they will be artistically meaningful. And I guess this is where the artistic value comes from. I want to arrive at kind of objects that are kind of artifacts that are weird, that are impossible to create ourselves. And that's, you know, the bottom end about non-human creativity. I want a machine that does something that we can't do ourselves. And of course, you know, since we can't do ourselves, we don't have the tools to appreciate it aesthetically or artistically. And yeah, I want it to be blurred in this kind of thing because that's how it is. Now, a very natural thing that emerges, you know, if you start, because, you know, I work in this kind of field almost more than a decade. And there is a very subtle point here that it's also a trap. At least it has been a trap for me, that when you try to do something that it's meant to be non-human, and it's meant to be computational and machine generated, sometimes you go for a design that purposely eliminates the possibility of something imitating human-like behavior altogether, which is something I don't do here. So the idea is that non-human doesn't necessarily mean that it won't, that it will always be different than what humans can do. Doesn't necessarily mean that it will always look different than what's, you know, that human production, and doesn't necessarily mean that it doesn't involve human created things. So in this case, it's rather the contrary. I have a machine which is meant to create multimedia content based on a complex evolutionary pipeline. There are just a few rules in there. The rules are, you know, are nothing like do this or that because this is wrong or something like that. They are just rules of how to respect certain hierarchy and how to enable and to initiate the whole process and how to make sure that the process will always continue whatsoever. And other than this, there is a very complicated network of interactions between semi-independent modules. So you have the crawlers and they just, you know, download data and they send them over to a pool. And then you have another software module that tries to make sure that the pool is always updated and in time. And then you have the synthesis module that takes content from there and does something. And you have a comprehender module that also does something there. So essentially you have the results of all these cross interactions of a series of modules that are not aware. They are not aware of what other modules are doing. So essentially, this is how I try to implement, you know, as the aggregate of all this is how I try to implement a totally computational take. But I haven't used any kind of measures to block human things that might look human-like. I haven't done that. And actually, what I want to do and what I experiment in this process is that I trust this system to repurpose and to interpret human culture. So I feed it with what we humans ourselves create. So it's not us to generate like multimedia content entirely on its own. It's rather asked to be inspired by human culture, to be inspired by human text, human language, human poetry, human videos, human things whatsoever, and to come up with its own versions of that. And I believe that it is very, very important. Probably the most important link in all this system is the repositories that I rely upon in the first place, like YouTube, for example. YouTube is an amazing thing. It has billions of videos about everything. You know, you can find everything here from sports to paintings to art to, you know, people sitting in their bedrooms, you know, talking nonsense. And all this is a quite important footprint that we humans live in the internet. So I ask a machine to draw upon this content, but without the normal human judgments. without trying to separate and say, okay, this is art, this is not art, this is interesting, this is not interesting. It just follow the way that these things relate with one another, and tries to come up with its own takes on things. And of course, this is a very first experiment. I plan to refine the process in the future with maybe implementing more rules, maybe losing a bit the rules, just to see what kind of things that may result and what would ultimately allow for more computational behavior. This is my goal.
Thank you. I think this is very interesting work, according to the point of view that what is art for machines? And art, yes, a machine, art for a machine is not art for humans. And but it's interesting because you use the human media and transform the human media to create art for machines. And thank you.
Yeah, no, I will just make a small comment on that. I totally agree. I have no answer. I don't know what is art for machines. I try to figure out, but I just thought in this project that, okay, art for machines is of course not art for humans, but it doesn't necessarily mean that it can't draw on human content. So let's have a machine take human content and see what it can do with it. But I have no answer. I'm trying to figure out myself, and probably it will take like 30 years and we will still be wondering the same thing, what is art for machines? But we are getting there at some point.
Yeah, some point. Thank you.
All right, so yeah, thanks for the discussion. So Marinos, I have to say I was really interested in the paper and the talk. Mainly because I watched a film or I read some concept by a modern Austrian philosopher, Arne Avanesyan, who talks much about hyperstition, and that's why mainly I was really interested in the talk and the paper. So yeah, thank you once again. And now let us move on to the next talk, which will be by Redouane, Dahmani, Sven Boogmans, Arne Meijs, and Daan van der Berg, who will be presenting, if I'm correct.
No, you are not correct.
I'm not correct.
No, it is Redouane Dahmani is going to do the presentation. So I think you will have to make him co-host or something. But I will do a little bit of introduction because these three gentlemen, Redouane Dahmani, Arne Meijs, and Sven Boogmans, and they're all here with their cameras on. Hi guys. They used to be my students last year, so they graduated last year on a very similar topic, which originally comes from EvoStar. I see many people here from EvoStar and from Gecko also, so yeah, they might recognize part of the work, although we made all new images and stuff, so it looks really nice. And what they did was, you talked about the earlier endeavors, Victor, of AI. What they did is they took a very, very classical AI algorithm. They took the simulated annealing and to approximate images from sets of polygons with fixed numbers. And that was an experiment that was done before, and it failed completely. They hypothesized that it had to do with the cooling schedule, and they did a very nice job in actually solving it. So on top of graduating in their spare time, in their own time, I should really say this, is no credits, no money involved, nothing. They really took up the task, because I'm very tough when it comes to writing papers, of course. It's different than a thesis. To write a paper about it, to make new images, to make all the data publicly available so you can download it all. I think also the source code I read. Did we also make the source code available? Yeah. And I think they did a really nice job. It's tough for students to actually write a paper, so I'm really, really proud they made it to a paper, and they got the paper actually accepted in your workshop, Victor. So therefore, did I say everything? Yeah, I think so. Without further ado, so if anyone asks some really, really tough questions, please bring it on, but I might help a little bit if it becomes really, 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 really tough. And without further ado, I would like to give the floor to Redouane Dahmani, the first author and basically the inventor of the paper. So.
Okay. So
Thank you,
Redouane.
Daan, for the introduction. I will now share my screen. Let's see, it's over here. Yes. Okay. I think it's visible, right? Yeah, okay. Well, thanks for the introduction. My name is Redouane, and I will be presenting our work today on Paintings-from-Polygons simulated annealing. Yeah, Dan already introduced us, so I'll just start. I will begin with the definition of the Paintings-from-Polygons problem. So, in Paintings-from-Polygons, we try to approximate paintings by using multi-layered polygons that we put on the canvas, and we try to optimally arrange those polygons to eventually form to approximate the painting that we are trying to target. And these polygons all have a color and are semi-opaque. And the Paintings-from-Polygons problem, we start off with a random constellation, as you could have seen in the beginning of the video on the right. And then we iteratively try to search for optimization, for improvements. And these improvements are calculated by pixel comparison between the current constellation and the target painting. And this improvement can be calculated by using the mean square error between those difference, between the comparison. So how do we modify the current constellation? Therefore, we use mutations, and we use 4 mutations in the Paintings-from-Polygons problem. I'll go over them one by one. The first mutation we have is the change color mutation. In this mutation, one polygon gets its color changed. So in this example, you see the green square over here, which gets turned into a blue square. Note that also the opacity of a polygon can be changed with this mutation. The second mutation is the move vertex mutation. In this mutation, one vertex gets moved from a random polygon. So for example, here in this simple constellation, the triangle has one of its vertices moved to a random location on the canvas. The third mutation is the transfer vertex mutation. In this mutation, one vertex of a random polygon gets transferred from the polygon to another polygon. So for example, the square here loses one of its vertices, and the new vertex will be placed on the triangle in this case. Note that the receiving polygon will receive the new vertex on one of its current edges. So this vertex will be placed on one of these edges. In this case, it's over here. And the final mutation that we have is the change drawing index mutation. And the change drawing index mutation changes the drawing index of a polygon, and the drawing index basically is of importance because it depends which polygons are placed on top of each other. So in this case, the square has a higher drawing index, and in the new case, it has a lower drawing index than the triangle. So those are the 4 mutations with which we can modify current constellations to eventually optimize the constellation and to approximate a target painting. Well, the previous study was done by Pauw and Van den Berg. This Van den Berg is the same Van den Berg as we work with. And they used 3 optimization algorithms to solve the Paintings-from-Polygons problem. They used the hill climber, the simulated annealing, and the plant propagation algorithm. And as we can see here on the right-hand side, the simulated annealing algorithm clearly performed the worst of the 3, and the hill climber performed the best. But instead of leaving it there, we tried to improve the simulated annealing algorithm, or at least the performance of it, by using new and adapted cooling schedules. So before we dive into the cooling schedules, I will just run over the simulated annealing algorithm first. The simulated annealing algorithm iteratively tries to optimize the problem. And every iteration, a mutation is done. And this mutation could lead to an increase or decrease of the mean square error of the evaluation of the constellation. And if the mutation leads to an improvement, the mutation will always be accepted as the new state or as the new constellation. But the mutation could also lead to a deterioration, and these are sometimes accepted. And whether it is accepted or not depends on this equation, the Boltzmann factor. So what it's saying is actually that the chance of the mutation to be accepted is depending on two variables. First, we have the difference in MSE, so that's the mean square error. And that's basically saying that if the new constellation is getting very much worse, or it's a very big deterioration, the chance of the mutation to be accepted gets smaller, and vice versa. If the deterioration is just very small, the chance of being accepted is getting higher. Then we have the second variable over here, that's the temperature. And for the temperature, if the temperature is very high, the chance of the mutation to be accepted is also very high. And if the temperature is low, the chance of exception is lower. And this third step of the simulated annealing algorithm is actually the key component of simulated annealing, as sometimes deterioration is needed to improve on the long term, to escape from a local optimum. So as we've seen, the temperature has a critical influence on the accepting of deteriorations, as too high a temperature may lead to too many deteriorations, and too low a temperature may lead to too little deteriorations. So we actually have to find a balance between these two temperatures, high temperatures and low temperatures, and therefore we use cooling schedules. These are the 9 cooling schedules that we've used for our study. Actually, the one in the top right corner is the same cooling schedule that Pauw and van den Berg used, and all the other 8 are newly used cooling schedules for this problem. So the first 2 are actually the same cooling schedule as used by Pauw and van den Berg. These are cooling schedules that were used by a study from Gman and Gman, and we just adapted one parameter in this cooling schedule, which is the C parameter, which basically lowering the temperature of the cooling schedule, but following the same curve. Next to that, we used 4 monotonically decreasing cooling schedules. So we have here the linear cooling schedule, the staircase, the sigmoid, and the geometric. And after that, finally, we have used 2 reheating cooling schedules, which are the linear reheat and the cosine. For our experiments, we've used 9 paintings, which are shown over here. And for every painting, we used every cooling schedule, and we ran that 5 times. And every run consisted of 1 million iterations. And for the constellation, there was a non-changing total of 250 polygons and 1,000 vertices distributed over those polygons. And in our results, we actually found a pretty clear pattern. So these are the results of our experiments. On the vertical axis, we can here see that we can see the normalized MSE. So that's the normalized mean square error. So that is factually just the final score of a cooling schedule of a run. And on the horizontal axis, we can see the cooling schedule stated. And the clear pattern that we found is actually repeating itself for all the different paintings. And that is that the cooling schedule of Gman and Gman with the parameter C setting to 1 is outperforming the geometric, which is outperforming the linear reheat, etc., etc. So this was actually a pretty convincing result that we found in our experiments. Next to that, we also have we have these red bars in the background of the graph. These represent the mean temperature of a cooling schedule. So this is the mean temperature of one run of a cooling schedule. And we actually found a pretty interesting result in that as well. So what we see here is on the vertical axis, we see the logarithmic value of the mean square error. So this is the mean square error out of 5 runs. And on the horizontal axis, we see the logarithmic value of the mean temperature of a cooling schedule. So note that on this log-log plot, 7 out of 9 cooling schedules seem to follow this linear relation. which roughly translates to the fact that the solely variable for a cooling schedule's performance is the mean temperature. But we have two exceptions, which are the linear reheat and the geometric cooling schedule. They seem to be outperforming all other cooling schedules based on their mean temperature. But to end off with a more visually appealing result, I have some paintings here. And this is on the left side, the original painting, which is laid with an ermine by Leonardo da Vinci. And here on the right-hand side, we see 9 approximations, which are done with our simulated annealing algorithm. And for a comparison, on the right bottom side, we see the cooling schedule that was also used by Pauw and van den Berg. And if we compare that result with all other paintings, we can confidently say that we achieved our goal of improving the performance of the simulated annealing algorithm. And it's actually a pretty useful tool to solve this problem. I want to thank you all for your time, and thanks for being here. If there are any questions, me and my colleagues will be glad to answer them. Thanks.
All right, thank you very much, Redouane. And yeah, do we have questions for the group?
Yeah, can I be heard? I have a quick question.
Mm-hmm.
I'd like to thanks for this very interesting work. Like you have been invested so many kind of combination of the parameter. I actually have a very quick question, which is that because the Mona Lisa suddenly reminds me of a very old demo shown online, I put on chat. Definitely that is very simple. It's basically equivalent to the simulated annealing with like a 0 or it's a boundary temperature where the acceptance of the new case is only happen when it's better. So I want to ask when you compare your very detailed study with some of the very simple, for example, simple genetic simulated annealing, what story we can take from this, from your detailed study on, for example, different like a linear or sigmoid or like different annealing schedules, such as, for example, you tried the linear ones, you tried the reheating, but I want to hear from your understanding or your opinion on what these complex schedules bring, what kind of benefit they bring us compared to some very simple example. Yeah, as I put in the chat, so simple, all the school ones.
Yeah, so I think to answer your question, we can look once again at this this graph. And one interesting thing that we found is that it didn't actually really matter for 7 out of 9 paintings which cooling schedule we used. So the complexity of the cooling schedule did not really matter, or the characteristics. But mostly what counted was the mean temperature of the cooling schedule, which almost solely decides what the performance was, with an exception of these two, the linear reheat and the geometric. And we still are planning to do some extra experiments on setting a fixed mean temperature, so we could really compare one-to-one which cooling schedules are actually performing better than the other. If that.
Oh, I see. Is that, do you think it's possible, for example, to combine the simulated annealing with genetic programming, where you combine, where you introduce a population of, for example, your current canvas, not only one that you have been keeping doing the simulated annealing, but a population, for example, a pool of the examples, where you only choose the best that fits after your tweaking?
I'm not sure if I can answer that question. Maybe Daan has something.
Yeah. I can. Ying Tiao, thank you very much for your questions. So to come back to your, I'm going to answer everything because there's 3 questions in your question. So first of all, this schedule that you see here, I think that this is a really strong result because it tells that whatever the shape of the simulated annealing you have, basically the temperature is a very good indicator of just the temperature. It doesn't matter what kind of shape you have in the temperature, but just the average temperature of the schedule is a very good predictor for the performance on this problem. I should be careful with the acceptance. The very interesting acceptance of the two outliers, which are performing better. Now that's the first answer. The second answer is about the simulation that you put in the chat, and I've seen it and we know it. And basically, that is the root of all this work. It's by Roger Johansson. He is, I think he's from Sweden or from Denmark or somewhere up north. And the original paper that Misha Pao published with the failed simulation annealing, that paper is based on that work that you just suggested. But the main difference is that what Roger Johansson calls genetic algorithm is, in my view, just a hill climber. And second of all, it looks like Roger Johansson puts in additional polygons and vertices. And that is, in some sense, scientifically speaking, is not fair. Because if you get more polygons and more vertices, of course you get a better approximation. So the main difference between their work and all the scientific work is that the number of polygons and vertices are fixed. And we're just optimizing. That's it. We don't add new polygons. And now for the third part, I hope I answer everything, and otherwise just come back to me, please. The third part of your question about the population, this is possible. Actually, the work that was previous to this one, and this is again the one with the failed simulated annealing, the work by Misha Pao, it has a population. Can you go back to the plant propagation, Redouane?
Yes.
So if you look at this slide, Yingtao, then the simulated annealing completely failed in this study. The hill climber is actually closest to the work of Johansson that you just suggested, except for that we fix the number of polygons and vertices. And the plant propagation is actually, it's not completely a genetic algorithm because it doesn't contain crossovers, if you understand what I mean. But it is population based. So you have a population of polygon constellations and they mix. So I hope it helps a little bit in, so there are possibilities of making population based algorithms that work for plant propagation. And there are still plenty of options left for like genetic algorithms or like CMAES or maybe variable neighborhood search. There's still plenty of options, but you have to keep those, unlike Johansson, you have to keep those vertices and polygons fixed. You cannot add new polygons because then the comparison becomes unfair.
I understand. That perfectly answers my question. Thanks. And I really believe the resulting is very beautiful. Actually, the very moment I saw the Mona Lisa, it just reminds me of like a previous attempts to painting Mona Lisa with simple polygons. I saw that actually when I was in middle school, and I keep remembering that for like a decade. I think this work also is just like, how to say, as memorizable as the previous one. So I really like it. Thanks for answering my question.
谢谢你引导。
Whoa,
是很美的，谢谢。
Yeah, thanks. You speak perfect Mandarin.
Well, can I make a question?
Sure.
Okay, so actually I have a question and also a comment. Actually, some feedback that I would like to give. I find it a little bit disturbing that you didn't mention Roger Johansson's work during the presentation. And I think that you should, and I think it's important that you as a student, and I believe you have completed your graduation, but to realize that it's important to mention the works that inspired your own work. And in that sense, I think this is something that you should have done during your presentation, because otherwise it appears that this work is starting from a place where it really isn't. I'm also very happy that you fixed the simulated annealing, because in the previous study it was quite obvious that the initial temperature was way too high. And now it works. Of course, it works. Simulated annealing is a well-known algorithm, and it will probably work very well in this type of circumstances. I'm kind of confused with all the schedules that you tested, because, well, I couldn't have read the paper, so I don't know the details. If I understood correctly, you are proposing or using a constant temperature throughout simulated annealing. That will work just fine. This has been tried before. There are several papers regarding this issue, and you'll find out quite easily if you do a Google search that keeping a constant temperature, provided it is low enough, will lead you pretty much to nearly optimal solutions. So my comment and my question to this paper is, I find it very interesting in some sense, but at the same point, all of this is well known. And while I understand it, it can be interesting from a student's perspective just to figure out if the previous results actually hold in the problem. The fact still remains that all of this is pretty much well known. So again, maybe having a stronger, and I haven't read the paper, but maybe having a stronger analysis of the state of the art could actually have saved you a lot of work. Although it's always interesting to test for ourselves. But my real question here is this, and considering this is a workshop on computational creativity, I don't see the relation. And this is my criticism and my question to this work, and also to the original work by...
Your mic.
The microphone is not working.
Oh, sorry. Now it's working. Let's assume your work is working fine, and it is, as far as I can tell. So you run an algorithm, and in the end, you have an image that closely, very closely resembles the original image. What's creative? Where's the creative process in that? In what way will that enhance my creativity? In what way can I generate novel products? What's the point? And I don't want to be offensive, you know, but I really totally fail to see the point in this, because if you are successful, in the end, you get exactly what you have started with. So other than a fetishism to see the process developing or something like that, kind of an animation, I don't see the goal. Let me just phrase this: in a computational creativity context, I don't see the goal. And sorry for taking so long to make.
No problem. Thank you for the question, and thank you for the feedback. I'll give to you that it's mostly a technical subject. But however, I still think, from my perspective, that there for sure is some creativity in this, as if this works very well and if you come very close to a painting and you can almost recreate a painting by only using polygons, I think we can in the future maybe discover some properties of different paintings or different styles by deconstructing them into polygons, and maybe there's some useful...
Let me, sorry for interrupting. Let me be, okay, really provocative.
Yeah.
A pixel can be approximated by a rectangle or a square, and hence it's a polygon.
Yeah.
So you could always have done exactly that. And I know I'm being reductive, but I really don't see where this is going.
Yeah, for sure you can approximate every pixel with a rectangle. But I think we're looking also at bigger structures within the paintings, and not only, because if we would use a square for every pixel, it would be pretty much a pretty easy problem to solve. But that's not the point. That's not what we're doing here. We're trying to use less than so many polygons to approximate the paintings.
Red, can I add to that?
For sure.
So, Penousal, thank you very much for all your questions. Let me address all three that I heard, and if I don't answer them enough, just come back to me, because there was indeed a lot of questions. First of all, about the reference to Johansson. So, in the original paper, which was originally the study work of Redouane, there was a discussion like, should I use this reference to Johansson or not? And I said, well, just use the reference to Paul van den Berg exactly for the reason of, and maybe you're right, let me tell you that before, maybe we should have mentioned him, because credits should belong to people that do good stuff. But the problem with it is that the original work of Johansson is not suitable for optimization from a pure optimization perspective, because there's vertices and polygons added. And this, again, and because, to be really honest, I think that it says genetic algorithm and even genetic programming, I think, on the blog post of Johansson. And it's not nearly a genetic algorithm or genetic programming, it's hill climbing. And I try to teach my students to be very rigorous about this stuff. But maybe we can, in the future, like put it in somewhere to accredit it without referencing it content-wise, maybe. So that might have been, anyways, if you would consider it a problem, I would be the one to blame, because the guys have definitely looked into that. Then the second question you had was about the constant low temperature. There are indeed some papers about that. They're all referenced in the, well, they're not all referenced. Some of them are, because, you know, simulated annealing, I think it has 35,000 papers or something, like really a lot. But there are some very interesting papers which describe exactly what you say, that the low temperature, keeping it low for a long time, it gets the best results. A paper by Noorani, for instance, but also that references the paper by Jeeman and Jeeman, but also these paper by these two Chinese guys. I don't remember their names, but they're referenced. What I haven't found, but this is maybe my thing, is that the performance is actually scaling across the average temperature. So if the average temperature increases, the performance decreases functionally with it. Maybe, yeah, maybe there's some paper.
It's not exactly, they don't scale exactly with the mean temperature, because the mean temperature doesn't apply and doesn't measure well the actual behavior of some of the schedules. So that's why you have those two outliers, which I believe it was geometric and so on. The mean is not applicable there, because although it's the mean temperature, the algorithm is never, almost never, at that temperature. Maybe this wasn't clear. If I could draw, I could explain this better. So that's the reason why you have two outliers, is simply because the mean is not a good descriptor for the behavior of those algorithms. of those schedulers. Okay, so that's the reason. It's the wrong feature to characterize the behavior. It's okay for the others where the mean is more significant.
Well, that's very interesting. So that will be a really interesting follow-up to look at.
If you draw it, just the schedule, and you see that the mean temperature, for instance, for a geometric or something like that, the mean is actually somewhere here, and the algorithm is only in a short period of time at that temperature. So it's a very bad descriptor. While if you have a line or something that is more, for instance, a sigmoid or something like that, it will probably be a good descriptor. So it's actually very intuitive. The results that you are getting are very intuitive, and they confirm basically what is known about.
Wait, one second. You say this is a very bad descriptor, but at least for this problem, I do not completely agree. And this
no. Just for those scheduling algorithms, because they don't behave in a way that mean. Do you see what I mean? It depends. It will be a good descriptor for some scheduling schemes and a bad descriptor for others, almost independently of the problem, because some of the scheduling schemes have a behavior where the mean is not representative of the actual temperatures that the algorithm behaves at. Maybe this is a confusing description, but I think you got it.
Well, I think it's nice to look further into it, because you can make these shapes really. But there is a third question or remark or a provocation, like where is this going? So basically, the reason that this whole thing exists is not because it's so scientifically speaking important, but because people get drawn to it. And so every year I get these, like either in conferences, but also from students, I get people who want to work on this problem. And basically what I did, because Misha Pao originally came with this problem to me, like, oh, this is so interesting from a heuristic point of view. And I said exactly what you said, like, what's the point approximating an image? So basically I use this to tailor a set of problems for students to actually understand the behavior of these, because if you make it very tight in terms of fixing polygons and vertices, it really provokes some questions about how do these algorithms work. And that's why it's good from an instructive sense. But second of all, and this is in the original paper, exactly as Redouane mentioned, there are some upper and lower bounds to the number of vertices and polygons that you need to approximate a certain image. So if you want to say, like, where is this going? In my fantasy, but it's still far off, I should give you that, where this is going is to a new form of image compression. So if you find the right vertices with the right shapes and the right transparency, the right colors, then you can have a very, very small representation of a very large image. Maybe.
But again, then that has been done in the beginning of genetic programming. You'll find papers, for instance, by Wolfgang Benzav trying programmatic compression and several others. And the idea was pretty much the same. I do believe programmatic compression, it's a very interesting subject area. And I totally understand you wanting or proposing this problem to your students. It's a nice way to get them going, to get them motivated and so on. I'm not taking anything away from that. I'm just saying that in the scope of computational creativity, I really don't see it. But you know, it's just my opinion. It's really not something that you need to justify or whatever. But actually, thanks for explaining me this idea of using this as almost a problem for your students and a way of them to understanding the algorithms. I do believe there is a lot of value in that.
Thank you for your nice words. So first of all, I don't know the papers that you mentioned. I'd really like to get them. So if you find a link or something and you could mail them to me, then I'd be
Sure.
And about the second point about computational creativity, I must admit to you that we were completely unsure about whether this would be in in computational creativity. So we just submitted it to the workshop, and actually the reviewers said exactly the same thing as that you say. It's like, is this really computational creativity? It's a bit on the fringe. And I think that maybe Victor or some other workshop organizer said, like, just put it in and let's see where the discussion goes. Maybe it does add, maybe it doesn't. You just have to. So I completely agree with you on that.
You are almost correct. That's true. Yeah.
Yeah. And thank you for your kind words, Penousal.
Sorry, I just passed one of the earliest papers I remember on that. Is from 1995. I'm getting old, so I know these references. It's by Nordin and Benzaf, and I believe you can take it from there, because surely the other papers working on this surely reference this early paper. Okay,
cool.
I hope that helped.
Cool. And it's really about image compression, right? Cool. Thank you.
Yes, it is. It's about image compression using genetic programming. In this case, they segmented the image in rectangles or squares. I don't remember. It was a long time ago. And then trying to find an expression function that approximated a small area of the image. Then a few years later, let's say, I'm guessing 1998, 1999, maybe I'm wrong, there was at least 2 other papers that relied on segmentation, one using polygons, other using some irregular shapes that first segmented the image and then tried to find a mathematical expression for each of the segments. I believe these ones would be the most interesting to you. I don't know the reference by heart. I would have to look into probably my PhD thesis or something like that. But I'm sure they reference this paper. So because that's the way I got to them. So it should be easy. Okay, thanks.
Obrigado.
Related to image compression, I have a quick question, if you don't mind. Why do you use the mean square error as the error function instead of structure-based similarity or another one? You can use it by changing that function. You can perhaps go on different paths on perhaps approaching something creative, or I don't know. It's just a simple question. Why MESA?
Shall I take that or you?
Yeah, well, for this paper, I didn't really study that topic of using the MSE. I don't know, maybe Daan, did you?
No, there's no specific reason whatsoever, João. So basically,
is perhaps you used my question was mean square error to compare to another existing work or not?
Yes. So basically, maybe it comes even from Johansson. I'm not really. I have to be careful here. But when Misha Pau, he was the previous student who was working on this. When he was working on this, I said, like, you really need to make a strong comparison between the beginning of the constellation and the end to see how your algorithm is performing, right? If it really becomes that, and not just by eye, but you have to make some objective measurement. And I think he introduced the mean square error. And I'm
but by my mean square error, perhaps you're going pixel by pixel instead of by larger structures or by something that appeals to the human eye.
Yes. Oh, yes. Yes, you are very right. Yes, you're very right. And one of the bachelor student projects that I have open currently is to compare, like to let people grade how good they are, the comparisons, and compare to the MSE. Because we found, just anecdotally, that if paintings which have a face, like the Leonardo paintings, that they get, that then we all go, wow, as the face is approximated very well, while there might be very big MSE differences, very big errors. in the background, right? So what kind of error measure did you just propose? Let me just take a note of that.
Structure-based similarity metrics, there are a lot of them. I'm not very up to date to them, but if you go to Wikipedia, you have a list of them and some formulas. So that goes, that's another approach based on structures, blobs, I don't know. It's not based on pixels, so you can diverge creatively just by that.
Interesting. Thank you. Obrigado.
All right, so I would say I would have one last question now. You mentioned that you will put a source code somewhere. Can you please tell a bit more about implementation? What did you use technically? What language or what framework?
Well, everything is has been programmed into Python, and we've I don't know for sure what packages we all use, but everything is stated.
We used Pillow.
Oh, there we go.
For the image generation.
All right. Yeah, I believe we are finished with discussion. As you have maybe already noticed, I always love to give a room for discussion after the presentation, and so I normally also don't stop a speaker when the time is left or something. So be sure that you will have your time to discuss and to present. So okay, so the next presentation is an interesting one in the fact that it will be presented by a family, if I'm not mistaken. So all of the 3 authors have the same surname, Rebelo. I know Gus,
family. It's not a family.
It's just a coincidence.
Just a coincidence, yes.
Oh, interesting. Okay, so I believe José Rebelo will present.
Yeah. Hi, everyone.
Hi.
So we thought we had to record a presentation for this conference, so we recorded one, and we are going to show to you. I'm going to share my screen, and hopefully you can get the audio from it also.
Okay.
Hello everyone, my name is José Rebelo, and I'm a design and multimedia master student at the Center for Informatics and Systems of the University of Coimbra, more precisely at the Computational Design and Visualization Lab. I'm here today to present you some experiments with algorithmic web page design. This system is being developed along Artur Rebelo and Sérgio Martins Rebelo. As the name suggests, this system explores web technologies and environment in order to create data-driven web pages. Nowadays, web pages perform an important role in the contemporary world, since they are the main interface for someone accessing data available online. With the publishing of the first web page in the early 1990s, the web environment has been in a state of constant evolution. Recent innovations on web development and design have produced deep changes in the way that people interact and communicate online, thus making the current web environment a suitable ground for the emergence of creative explorations where computational design technologies will allow development of innovative, data-driven and generative web design systems. During the early times of the World Wide Web, most designers had harsh aesthetic limitations imposed on their designs. Most of these restrictions were due to limitations on screen sizes and typographic choices, since the only accessible fonts at the time were those that were available in the operating systems. That gets us into the state of web pages nowadays. By performing a quick search around the web, we can see that web pages have become somewhat repetitive and tiresome, since most of them are designed under the same rules and developed using the same frameworks. However, in recent years, we began to observe a further exploration of new layouts and interactions. Most of the times, these experimental works explore the web medium in a way that it is as important as or more than the information transmitted on the page. Algorithmic and data-driven approaches are often the key tools employed, giving the possibility to designers manipulate the visuals and the content in a dynamic way. With these aspects in mind, we were keen to build a system that explored some aspects of web design. This system is a work in progress that explores computational design technologies in the context of web design. Our motivation behind the development of this system was simple. We wanted to build tools capable to avoid streamlining design development, use the web environment to develop visual experiences, promote a change in the paradigms of design in digital communication, and finally, explore the artistic potential between design and development technologies. As we said before, the system experiments with algorithmic design to create a more diverse web environment. The system generates web pages employing 4 main modules. The first one, data processing module, followed by content analysis module. The third one is the content styling module, and finally, placement and design. With that being said, the workflow of the system is described as follows. The generation process begins when a user inputs a search term. The data processing module performs a search in the Wikipedia API to obtain data. If the data satisfies the user, the content is sent to the content analysis module. After that, the content styling module styles the content based on the previous analysis. Finally, the placement and design module creates the page according to the styles defined beforehand. Subsequently, the page is generated. After the page has been generated, users may fine-tune the generated page by refining some visual variables in a parametric way. Now, delving a bit into how these modules work. Starting by the data processing module, this module gathers the data from the Wikipedia API based on a term inputted by the user. Then, it removes all attributes returned with the content. These attributes can be things like inline styles, classes, and other DOM manipulation attributes. Then, once the data is returned, the module splits it into 2 copies. One copy goes straight to the front end, the other one goes to the server waiting to be analyzed. The users also may change the text displayed on the front end if they wish, and the new text is sent to the server with the changes. In the content analysis module, the content sent by the user in the previous module must be treated in order to be analyzed correctly. This analysis is as follows. Counting the words and their frequency, counts the HTML tags and their frequency, transforms contractions to their uncontracted forms, converts all the words to lowercase, removes non-alphabetical and special characters, finds and corrects spelling mistakes that may happen within the text, removes stop words, and employs an NLU network and lexicon-based analysis. This NLU analysis is based on NLP.js and lexicons developed by Sahif Mohammad. Sentiments are recognized on a positive and negative axis. Emotions are recognized in the local level, so that means each word is searched in a word emotion association lexicon. It recognizes colors using a color word association using the same processes as above. Then, the data returned from this module is compiled as a JSON file. Regarding the content styling module, this module explores OpenType variable font technology. This enables certain design attributes on the typeface to be changed. These attributes can be the weight, monospace, casual, slant, and cursive. The font's weight of each word is defined based on the word count. Each one of these other attributes is defined based on the average score of the sentiment multiplied by a random number from 0 to 7. This module then randomly picks a color from the 5 most associated colors to use in the background. Then, finally, the module defines the general size, the flow, and the patterns of the HTML elements where the content will be placed. The placement and design module has a set of predefined base layouts to place the content. Each layout is designed to convey a specific sentiment and emotion. We implemented 16 main variable layouts. This means 8 layouts for each emotion, and 2 variations of those layouts for each sentiment. The style of each element on the layout is determined based on the values defined on the previous module. After the generation, the user may visually fine-tune the output using the refinement interface according to their necessities and taste. We can see on this picture an up-to-date version of this interface. Besides this, the system has also the potential to be a functional co-creative tool. The users are invited by the same system to be included in the design process, being able to choose the content that will be presented and to adjust some visual properties generated by this output. This way, we believe that this is a useful tool for enhancing user creativity, especially for web designers in exploratory stages on their projects. At the time, we believe that the system may be used by general people to more easily generate web pages for presenting information about a thematic. So, right now, we are going to show you a version of the system running. You can also check it yourself by using the link below. So, this is our main graphic user interface for the system. As you can see, we have divided it by columns to make this easier for the user. As we said before, the first step on the process is to write an input. On this case, we'll use the word Joker. Once this field gets an input, the search button is enabled and the data is being retrieved. As we can see, the page is filled with text from the Wikipedia API with no styles. For this purpose, this information is valid and we can proceed to analyzing the content by clicking the Analyze button. This process takes a while, so we're gonna jump to the generated page. As we can see, our page has been generated and it has got some new styles. The styles that are applied on this page are by default the styles that these ambiguation pages get. So, for this new search, we're going to use the word piccolo. We're going to write it and click the search button and it's going to retrieve the data for us. As we can see, this data is a little bit too big for us. So what we're going to do is click the Make Content Editable button and select some of it and delete it. This will make our analysis a little bit faster. Then we are going to exit the Make Content Editable mode and click the Analyze button to begin our analysis. As you can see, the font size has been changed, the text direction has been changed, and there is some content repetition occurring on this page. But this is a bad example for what I'm going to show you next. This is a much better example for we to show how the control system works. The controls menu offers the user a lot of room to manipulate the final output. We can change font color, background color. Also, the font size and parameters can be adjusted to fit the user needs. There is also a toggle for applying movement to some words or all the text if the user wants. So, a quick recap. We have a system that automatically generates web pages using content dynamically gathered online. The content is gathered based on a search term inputted by the user. The outputs are generated throughout the employment of 4 main modules: data processing, content analysis, content styling, placement, and design. From a user inputted term, the data processing module performs a search in the Wikipedia API to obtain the content. If the content returned satisfies the user, the information is processed by the content analysis module. In this process, an NLU classifier and lexicon-based approaches are employed. After the content styling module analyzes the results and defines a set of visual variables according to the semantic meaning of the content. Finally, the placement and design module employs the necessary means to render the output. If the user desires, they may refine the generated output by adapting some values in a specific interface. This way, they may adjust the output according to their tastes and needs and export the result. Now, we're going to show you a few other examples of outputs generated by the system. As you can see, this system already is able to produce somewhat diverse and complex pages that offer some level of interaction. This was one of our main goals, not only to create static pages, but also to create pages that the user must interact with, whether it be on scrolling to find the content or clicking somewhere to reveal or hide it. So, guys, that's our presentation. If you have any questions, go ahead.
All right, thanks so much, José. And yeah, do we have questions?
I have one. Am I muted or am I?
We can hear you now.
Okay, yeah. Okay, so I feel like so it was really interesting. Especially at the end, it looked like kind of a weird dream version of the internet, which would be like you're clicking on all these buttons, you're trying to find information, they keep changing color and disappearing while you try to use it. So in that sense of a kind of, that part of it seemed like really fun and interesting. The part that I didn't understand, I guess you went past kind of quickly. You just said we use an NLU module by somebody else, and furthermore, then when you got to kind of show it in your talk, you said here it turns the text direction vertical. So I wonder if you could just spare a few thoughts about how NLU is used here, and yeah, how does that, because we're in this conference or a workshop on knowledge-based systems, so yeah, where is the knowledge? I guess the knowledge is in Wikipedia, but it's not just in Wikipedia, because whatever NLU thing you're using gets knowledge out of Wikipedia. So maybe. So
first, the text must be tokenized. Then this NLU.js analyzes each word according to each sentiment, and then it outputs some values. It analyzes some things like if the global analysis of the text is positive or negative, then it gives us a sort of numbers and parameters that go from negative values to positive values according to the analysis of the text. Also, the lexicons that we are using are, as I said, are developed by someone else. They are mostly word associations. So after tokenizing the text, we match each word to the lexicons in order to get some values out of it. And then we can proceed to choose the colors and the emotions that are associated with the text.
I apologize. I guess I feel like you're still glossing over some of the details. You match something into a lexicon, and then you choose colors. I mean, could you fill that out a little bit more so I understand how the lexicon is used, or like just a little bit more, because it's just basically that you say you have sentiments, you've got colors, but I just don't see how it all fits together into one organized system. It just seems like there's so NLU means sentiment analysis primarily, but how does that then relate to anything that the user sees?
I can reply. Basically, you may use an ALU to perform a global sentinel analysis of the getter text, and after use a lexicon-based approach to recognize the intensity of the emotions. And based on these results, you have, I think, 16 variations of layout that with multiple functions that can change some things in layout that are selected based on the results of this analysis. For instance, if you have a text with a positive sentiment and joy, a lot of joy, and for instance, an article about pizza not, but anything like this. The system will choose one template that you will select on template that we'll select placement functions that reflects better the joy. You define this by empirical exploration, and after you select the template to place the objects that reflects also the joy. But this is not a deterministic process because it's a random selection. They are the functions and the templates that reflects most the joy have more probability of being selected, and but can be selected another one in the same. I reply to your question. I don't know if.
I guess I understand a little bit better, but yeah, I guess maybe we could discuss it at another time because I think I don't really understand in detail, and I couldn't find NLU.js just by looking online. So maybe just
NLP.js. It's a typo.
Oh,
NLP.js. Yes, but use NLP.js only for sentiment analysis because they have a model, sentiment analysis model implemented based on natural.js, and you have not the knowledge to construct an NLP sentiment analysis function, and you texted you experiment with the NLP.js also to understand the intensity of emotions, but you cannot find a good data set. And because of this, you use a lexicon approach because the data is more reliable and more stable. Although the results are not very good. Sometimes are not very good. Sometimes are very good because you do also lemmatization of the text using, I think, WordNet, and to understand if the word you are using in the lexic have the same if the word you search in the lexic have the same same significance. But and I think it's better you can talk after because after using these results, you mapping some functions and templates by most of them defined by empirical exploration and by only exploration to reflect the sentiments and the emotions of the text, and in this way be transmitted in the layout. And I lost myself a little, but this is the really knowledge of the system, because you read some studies about font taste and some studies about how fonts can transmit, how colors can transmit a sentiment, and develop a set of functions that reflect, that try to reflect the emotions recognized on the text. I can send you after this the document talk about these emotions and the implementations. We'll make available the code very soon, and you can also send you to see if you desire.
Okay, more questions to for this paper. All right, so thank you very much once again for a very nice presentation and very good discussion. So I have a small announcement to make. So originally we planned to continue at 1 p.m. the 13 o'clock at Coimbra time, but because we had some longer discussions and presentations, we decided to take a break until 13:30. So it will be 13:30 in Coimbra when we will continue, and the 14:30 in GMT+2. So Germany, Netherlands, and this time zone. So I hope you all agree on that. So we will have a little bit longer break than planned, but I hope you can understand this. You will also get information about this in the Slack channel. So yeah, I would say this session is finished now, and we'll see each other in an hour.
Thank you, Victor, and everybody for the very interesting presentations.
Thank you, Victor.
Thank you. All right, so I would say we can continue, and let me share my screen first to show you what's left, or what is in the second session. So in the second session, we will also have 3 presentations, and afterwards we will have a small group discussion to wrap up the workshop. But first, let's watch the presentations. And the next presentation is by João Miguel Cunha, Pedro Martins, and Penousal Machado, who will be presenting knowledge in computational design, typography, emoji, and flags. So I'm stopping sharing, and I believe João can continue.
Yeah, sure. Let me see if I can share the right screen. So this is the one. Can you see the presentation? So it has some my name on top. So that's all that there is to see. Okay, so I'm going to describe a showcase of 3 projects from 3 different domains. All these 3 projects have different degrees of interaction with the user. So the first one is mostly a creativity support tool. The second one is a co-creative tool. And the third is an autonomous system. And in order to introduce these projects, and since we are talking about knowledge, I will show and introduce them in their relationship with knowledge transmission. So the first one, if you think of transmission of information, probably you can think of a situation like this. So you have a scribe at work, which he has sources of information, copies them, produces new ones, which are shared with people and then share knowledge. So this is an example of written communication, right? Because these sources use these characters, which we call letters, which brings me to my first project. So here, the letter A, you can see how it evolved. So from these initial symbols to this shape that we call the letter A. And if you look at existing typefaces, you see how they are very different from each other, and they can be classified as such. But one thing that you can notice is that if you analyze individual characters, so for example, the letter A, you can see that they follows this shape that makes what we believe is an A, right? So this A shape. And so from in all these fonts, in all these typefaces, they all follow this idea of what a given character should be. So what a should be or a B should be, even though they are very different. And if we analyze specific characters, there is also something very interesting and which is responsible for the quality of a typeface, which is the part sharing. So you can see how certain parts are shared between different letters. So for example, here the N, the M, the A share that part, and also you can see others. So you basically can see how you have different groups of characters, and you can see how these characters relate among them. So from one letter, you could potentially get to others. So for example, if you start with an N, you can try to produce others. So this is basically the idea for the first project. So the first project is called Type Advisor. It's meant to be a creativity support tool. So there isn't much creativity from the system on its own, but basically the idea is that it supports the user in designing typefaces. So the user designs certain characters and the system helps it in producing others. So the main idea is that the user introduces a glyph, then identifies these parts, which are then disseminated to other characters, and then the system generates these other characters based on these rules. So these part sharing between characters. And then the user can export the font and then refine it and produce a final typeface. And so the way it works is the user inputs a character, as you will see here, inputting the letter N. And as we've seen, we can identify that part, which can be called the shoulder and right stem. And then this is propagated to other letters. So basically, based on this idea of designing some characters and inputting into the system helps in creating a typeface. So here we are identifying parts of the L, which are then propagated to the H. So the H is produced by using the L and the N. And what's done here is then by changing a part of a letter, like for example here changing the shoulder of the N, then this change can propagate to the rest of the characters. So this system helps the user to increase the speed in which the typeface can be produced. And so the type advisor is divided into two components. We've already seen the first one, which is the part sharing, and there is a second one, which is the advisor. So this idea that the system allows the user advises the user in which paths the user should follow. So if I'm designing a font in a certain style, I want it to be similar to fonts that already exist in that same style, but without being identical, right? So those two main goals are so guiding the design and avoiding similarity excess. And so the way we do this is by using self-organizing maps. So these are techniques used in data visualization that reveal relationships between vast amounts of data. So for example, here, what happens is that we produce a sum for the letter A, which organizes how different styles can be related to among themselves. And so what happens is that the sums are produced for each letter. The user inputs a glyph, a letter, and then the system tries to find similar designs. And in this way suggests designs for other letters to the user. So for example, here you can see a person who has previously designed the letter A, and then the system will suggest possible designs in a way not for the user to copy them, but more or less know how, based on the letter that he or she has designed, how the other characters should look like. And so this is the first project. So it is related to this way of conveying knowledge. But if we go before the time of writing, so when there was no written communication, for example, if you go to the Paleolithic period, you probably had a person who would see like a bull running and someone trying to escape from it, and then the person would represent this knowledge in a wall for others to look at it and probably think, oh, that's a bull. And so basically the idea here is that the person sees something, and obviously here it's written bull, but might be another word, but it's the concept of a bull, and tries to find a way to visually represent it in order to convey the information to other people. And so the second project is based on this idea. So the second project is called Emojinating. And the idea behind it is that you have text, you have a concept, and it tries to visually represent concepts. And the way it does it is using three components. So the first one is called the emoji searcher. So it uses emoji, which are these characters that you probably know. And because they are used in written language, you have a lot of semantic information assigned to them. So for example, if you search for emoji for woman, you can get all of these based on the semantic knowledge that's assigned to them. And so from woman, you can get these. And then you have the second component, which is the concept extender. And the idea behind it is that you have a concept and you extend it to related concepts. So from theory, you can get to idea. And from these two components, what happens here is, for example, for one word concept freedom, you can get from freedom to universal right or to state of mind, and then get emoji for each of them. And then for two word concepts, you can get the emoji directly. And so the third component is what puts it all together, which is the emoji blender. So you have two emojis, blends them together. So with these three components, you have freedom and you have hot dog, and you can produce these two representations. So a hot dog composed by a dog and a hot pepper, so it makes a hot dog. And the system is implemented in this platform, and the user basically gives the concept. The system replies with potential representations, and the user says, I like this one, I don't like that one, and the system evolves and produces things that match the user sense of quality. And so these are some results that the user is able to produce, like for example, representation for income, for kind, obligation, objective, idea. And so the system can not only produce these ones, but much more. So we've seen two projects which are based on these two, are related to these two images. And I'm going to show you a third one, which is quite different from these two. So here you see a battle. So in a battle, you can see two things. So you see two groups of people. Here is the Battle of Aljubarrota. So it's a fight between the Kingdom of Portugal and the Kingdom of Castile. And what you can see here are these symbols that represent people. So if you don't have these symbols, people wouldn't know who they would attack, right? So they are mad at each other. They need to know who they should eat or not. You don't want to eat a friend. And so the flag is what represents the people from a nation, right? So this flag is from Portugal, and it helps to build this sense of identity for the people of this country. So if we put the flag into a timeline and we see how the flag evolved, we can see how it went from one to another, and some characteristics were maintained, others were not anymore. So if you focus on the last two, there is a change from a monarchy to a republic. So you can see how the crown is not there anymore, and how the colors change. And so this idea of a design changing because the entity also changes. So the change from a monarchy to a republic changes the design. So the idea here behind the third project that I want to show you, if we focus a little bit and we try to propose designs for recent events. So for example, in 2004, we had the European Football Championship in Portugal, or in 2010, a law that allowed same-sex marriage was approved, or fires that destroyed a lot of forests, or even for 2020, and this one is easy, it's the COVID flag. And so what we are proposing here is that flags are normally used to represent countries and other entity, so the identity of the entity. And what we are proposing is based on this idea of constant change and also easy access of information, we want to represent also the mood. So these changes in shorter time periods. And so the system would work as such. It is given flags, a text modifies the flags. So this is the main idea. And the way we do it is we need images for the flags, so this SVG data set. And so, for example, this Cypress flag can be divided into the elements, which can be given labels. And then we can gather meanings for each of these elements. So, for example, for the background, the color can be peace, so white color means peace. And for this copper island, the color means copper, the shape is an island, and so on. And by giving the SVG files and also these meanings assigned to each element, we are able, for example, by putting Canada plus island and getting the Cyprus flag, we are able to produce island Canadian flag, or plus copper, the same thing by changing the color of the maple. But we can go beyond this by using, for example, a color name list, which has colors and names assigned to them. And so, for example, if we still remain with the Canadian flag, when we put aquatic and we get this color, then we have an aquatic Canadian flag. And also emoji, as we've seen with their connection with written language, it's easy to get Canadian flag plus tennis, and then you have a flag that more or less resembles the Canadian flag, but it's not the Canadian flag anymore, obviously, but it was based on it. And so we are trying to answer this. Can flags also represent the mood of countries? And so it's based on this idea of I'm in a mood for something. It's based on constant change. And the way we do this is by accessing Google News, RSS feed, and searching for the country, retrieving news about this country, retrieving the titles, analyzing the titles, and getting trending topics. So for example, a few time ago, for Brazil, we were getting the topic oil because there was an oil spill there. And so using color, we were able to obtain these flags. So this flag with the gray, the dark gray background that represents the oil. And also we are focusing on design, but also important is the explanation. So what does each element mean? So in the Brazilian flag, you have, for example, the green background represents the rainforest, and then it follows this structure of element X represents element Y. And so we can also apply this to our system. So the gray background represents oil. And with this system, we are able to obtain results like this one, and these are quite recent. So for example, for Botswana, we were getting this flag. Upon analyzing the news, we realized that there were some mysterious cases of hundreds of elephant deaths. And also this one for the Bahamas, probably you can guess what it is. It's the tropical storm Laura, so a few days ago. But also many others, like for example, for Australia, representing fires, or for Spain, election, and many others. So we have presented three systems. So the type advisor, the emojinating, and the ever-changing flags. And the way these interact with the user are quite different. So the first one, as I've said, it's mostly a creativity support tool. Even though it has potential to be introduced more creative behavior and have the system also create with the user. The second one, it's a co-creative system. So it interacts with the user and makes changes to the results itself. And the third one is an autonomous. So the only thing the user says, it's the country that it wants to retrieve a flag for, and then that's it. Regarding knowledge, it's also very different between these three systems. So the first one just has knowledge about these relations between characters and just access it. The second one has knowledge that accesses, but also due to this interaction with the user, it also modifies this knowledge. So it tries to adapt to the user, tries to adapt to the sense of quality, tries to adapt to what the user wants. And the third one accesses constant information from the internet, and so its knowledge is not always the same. So you can see these three systems, and I've described them very, there's a lot of more details into it. So if you want to know more about it, you have papers also about them. I tried to make just an overview about them, but if you have any questions regarding these systems, please let me know. Thank you. Hello?
Yeah. So, all right, thanks, João. And let's start a question round. Do we have questions to João? All right, so maybe one question from my side. How did you came to the idea of mood representation by flags? So it's actually a really cool one, and I believe it could have some future. I remember there was some so I remember reading about some, you know, when the president or our chancellor has a press conference, so behind them the symbols are also from time to time are different to represent what's currently going on, and I can imagine this flag mood representation could have some influence on that. What do you think?
Yeah, I totally agree. I mean, like I said, this is still under development, and there is a lot of unexplored potential here, not only just by generating these flags, but also in terms of visualizing information, right? So these flags can be used to, for example, pinpoint certain events that might not be of our knowledge. So for example, the fires in Australia some time ago, probably people didn't know about them. And so producing flags that specifically focus on news about the country makes it easier for people to quickly see and quickly understand what is happening. So still on this topic, one of the tests that we did was use the flags, for example, the one that I've shown of Brazil with a gray background. And we did some user testing, and it was interesting. It was testing with Portuguese people, that it was interesting how many people didn't know about this soil spill, even though it was all over the news. And so most people would look at the flag and they would say, so we asked what they would think this change was and why. And they would say, well, Amazon fires. And so, and it makes sense because the green is changed for black. So probably the oil spill could be done differently. So yeah, I think there is a lot of potential here. To answer your question, how I came up with this was a joint venture. It's not just my idea, but it's something that we believe, also the other authors believe that there is a lot of to be done here. So this is just the first step.
All right, other questions, comments? All right, then thank you, João, and we will continue with the next presentation. Yeah, which will be by Jéssica Parente, Tiago Martins, João Bicker, Hardman, and Penousal Machado, and it will present working with type approaches on generative and evolutionary typography creation. It's a very good presentation. Yeah.
Yes, I will ask if I can share my screen and show you the presentation because I already recorded.
Oh, you want to show a recorded one?
Yeah.
Yeah, of course. Yeah.
So. Can you see my screen?
Yep.
Oh, I'm I'm Jéssica, and I'm a PhD student of University of Coimbra in Portugal. In this presentation, I will talk about some experiments on generative and evolutionary typographic creation. First experiment calls generative layer type design and explores the use of layers as a way of varying glyphs' weight. It was inspired by an article of the Computer, Graphics and Art magazine that explained a method to create textures through the application of layers to drawings previously made. To achieve this, we draw a series of glyphs and we develop a method to create layers with the same shape as the glyphs previously drawn, but on different scales. Here is an example of generative glyphs. For each glyph, we define the number of layers, we calculate the position of the point of each layer, and we fill each layer by a series of random characters and punctuation marks. Depending on our needs and tastes, we can create different glyphs. Later, we develop a more complex system to compose posters to a fictional conference using generated glyphs. The second experiment is the typographic identity that makes use of layers and rotations to add dynamism. These experiments appear in the context of the creation of identity and a website for True. Our goal was to create a typographic identity that could combine visual themes of connected aspects of the project. Since the concept of Anthropocene highlights the profound impact of human activity on the planet, we decided to use staggered layers, which suggest geological layering. We also use the concept of the spiral, which refers to the entropical aspect of environmental problems. In that sense, that negative effects of climate change, deforestation are not isolated problems, but tend to have unpredictable and ever worsening effects. To achieve this, we designed simple lettering composed by letters that constitute the word drop. Then, similar to the last experiment, we generated a set of layers to each glyph, in this case, bigger than. After that, we add the spiral concept by applying rotations to each layer. After the creation of the static logotype, we applied it on a website. We decided to use the movement of the mouse to change the parameters of the logotype. According to its position, we can increase or decrease the rotation and space between. Data-driven logotypes is another project divided into two systems that generated logotypes driven by data. We wanted to explore how data can influence the design of logotypes and how can they convey information. In the first part, we used the University of Coimbra in Portugal as a case study to develop data-driven logotypes for its faculties. The logotype created for each faculty was developed from its acronym. Every faculty has multiple courses and, consequently, a substantial number of students. So, having this diversity in mind, it becomes natural to choose various typefaces to represent this diversity. So, after adopting some typefaces, we overprint them. The main goal was to uniform the group characteristics of the chosen fonts. After the letter forms were produced, we need to find a way to fill the shapes. To each logotype, we decided to use information about the gender of the students, orange for female students and blue for male students. To distinguish the elements of each gender, we decided to use layers and apply a multiple effect. Their nationalities, which is represented with symbols, right triangle to Portugal, quarter of circle for countries with Portuguese as official language, the other triangle for countries in European Union, and the line to other countries. and the number of students in each faculty, which is visually represented through the density of the elements that compose the logotypes. Less students with less density, and more students with more density of the elements. Here, there are some logotypes generated to the faculties. The Faculty of Arts and Humanities, the Faculty of Science and Technology. We can see that it has more students because it has more density. In the Faculty of Pharmacy, we can see that it has more female students than male because it has more orange than blue, unlike the Faculty of Science. And the Faculty of Sports Science and Physical Education. And we can see that is the faculty with less students. After generating the logotypes for the faculties of University of Coimbra, we believe that the system could also be applied to represent other kinds of data. In this experiment, we generated individual logotypes for the students. We used academic data and decided to use fictional data because this kind of data is not available. For each course of each student, we collected the type of course, bachelor's or master's degree. We decided to use colors to distinguish between bachelor and master. But we also use the number of credits made by the user, that is represented by density, and the name of course, that is represented by symbol. However, these three variables were not enough because each student can have more than one bachelor's degree, for example. For that reason, we decided to use different layers to visualize different courses. For example, if a student made a bachelor's degree and then another bachelor's degree and then a master's, this will be the layers in the logotype of that student. Here is an example of generated logotypes. For example, the logotype for Alice, who made a bachelor and a master's degree in the same area, have the same model, but with different colors. This logotype is another example. You see landing masters because the letters are not filled in the blue layer. Maria is another example of this. Generative and evolutionary type design system is another project divided into two experiments. The first is a type design approach focused on skeletons extraction and their anatomical deconstruction. The project is divided into 4 steps. The first was the development of the skeletons of the glyphs. That was an important goal to us. We used an algorithm that extracts the structural lines of a binary image, and this is the result of the structure of an image. Then, we divided the skeletons into parts. To do that, we calculated the points that belong to more than 2 segments. Here, we apply different colors to mark different parts of the skeleton. After dividing the skeletons of different typefaces into parts, we wanted to recombine them. Therefore, we could generate a new structure. To do that, we calculate the corresponding parts between glyphs. Here are the structure of a generated H and an I and a J. The colors represent different typefaces used as input. And we fill the skeletons. We pick the width of the original typeface used as input and replicate its width. Here is an example of a generated A and a B. In the end, we add more parameters like color, modulus, and density to add possibilities to the system. Here is some examples of generated M's. The last experiment is an interactive evolutionary system that uses the design process of the last generative system. We decide to employ the genetic algorithm to evolve different populations of lettings. The evolutionary system, like I said before, evolves a population of letterings. and each individual represents a sequence of glyphs. The genotype of each individual consists of a list of tuples containing integers, and each tuple represents a stroke of a glyph. The attributes of each stroke are the input typeface, the shape scale, the density, the shape's color, the opacity of the shape's fill, the opacity of shape's contour, skeleton's opacity, and the width of the shape's contour. And the genotype of each individual is the lettering using the settings encoded in the genotype. Here we present an evolutionary process. We develop a graphic user interface to enable the user to visualize, select, and read letterings. In the beginning, users need to write the word to compose the lettering. Then, they can select the values of each parameter. And during the evolutionary process, users can pick the lettering that they like it most. You can see that right now, the results are converging to the taste of the user. We explore different approaches to create type. With these experiments, we noticed that it's possible to create dynamic glyphs with the use of technology. All the results are unique and different from traditional typographic creation. And they are constantly changing. They also make use of layers and colors that create textures and add dynamism to a typeface. They are also very helpful to combine different information and to turn an identity more appealing. We have also some experiments that use external data to influence the generated glyphs, by data from the students or even by the movement of the mouse to change a logo. And that can be really helpful to make an identity more unique. In these kinds of projects, it is also important to define the applicant, because most of the typefaces generated on the systems cannot be used on a long text. Identity and glyphs to compose titles are always a good place to apply these kinds of glyphs because they are rich on colors and details. We also develop an approach that uses a genetic algorithm and allow users to choose the letter forms that they like it most. And that is an advantage because it can provide a wide range of alternative designs that can unblock creative block. And that's it. Thank you.
And that is my presentation if someone has a question.
Yeah, so do we have questions for Jéssica? All right, so once again, I have a question. So this data-driven logotype, first of all, I think it's a very nice example of a knowledge-based design. So it's actually a really classic one, generative example. I could imagine, you know, kind of a social experiment, you know, put the names generated by the system on, you know, badges on the breast when you have a conference or a meeting or a party, and let people don't talk about where are they from and what they're studying, and because it's easily will be visible from the logotype. So it would be interesting what the discussions topic will be then, or what the discussion starter will be then. So maybe as an idea.
Yeah, that will be interesting. At the time that we made the logotypes, we remember to put in the t-shirts and something like that. And as I think that the greatest part of that project is that the logotype evolves. So if I go to a conference in my first year, the logotype will be really simple, and in the second and the third will be more composed and with more density. And that's thing, I guess, is the best part of the logotype.
All right. So, other questions or comments? All right. So then, thanks, Jessica, for a very nice presentation. Very good one. Yeah. So we will continue with the closing presentation for today, which is by Carolina Lopez, João Miguel Cunha, and Pedro Martins. And I don't know, I don't see Carolina Lopez in.
Hello, Victor.
Yeah,
I'll be presenting the work.
You will present.
Yeah. So can I share my screen?
So yeah, the stage is yours. Yeah.
Okay, thank you. Okay. So, can you see the presentation? Blank slide.
Yeah.
Okay. Hello, everyone. I'm Pedro Martins, and I'm here presenting this work that results from a master's dissertation by Carolina Lopes, which was done under the supervision of João Miguel Cunha and me. This work deals with the generative text illustration, or if I want to be more precise, it reflects upon the creation of autonomous systems that are able to illustrate text. So that's our idea, our initial idea. I have to say that this is preliminary work. You are going to see experiments. That's what you're going to see. You're not going to see final systems. Even the results, they must be improved. The quality of the artifacts must be improved. But this work has given us many ideas, and we are already working on these ideas. So as for the motivation for this work, I can say that we thought of algorithmic or generative processes. And when we talk about algorithmic and generative processes and that are able to, that allow us to create autonomous systems. And if we think about application domains, things like algorithmic or generative design come to our minds, or generative graphic design come to our minds, or generative art. So when we think about generative process, we usually think about these application domains. But how about generative illustration? Some might say that illustration is generative art. Some might say that generative illustration is a part of generative graphic design. Okay, but let's see it in a separate way. So how about generative illustration, or in particular generative text illustration? To the best of my knowledge, generative text illustration is a field yet to be explored. It's a field yet to be explored. And I think it's important to understand what text illustration is, what it requires. Text illustration can be seen as a visual explanation of text, or as a visual interpretation of text, or even as a pictorial matter that decorates text. So we can see text illustration this way. And if we have text illustration as a visual explanation, as a visual interpretation, how can we take advantage of generative processes in text illustration? There are some advantages, properties associated with generative processes that we can take into account. We can repeat patterns. We can have a modular system. We can parameterize the system, and we can introduce randomness. But these are general properties of generative process. But when we think about text illustration, we want more than that. We have to think carefully about what are our goals, our requisites. And we want, in the end, we want to provide a visual clarification of the text. We want to provide a visual interpretation of the text. So we want to provide a visual representation of the text. That's what illustration is. And it's a good idea to follow a data-driven approach. So we can see generative illustration, text illustration as a form of information visualization, or even a form of data art. In fact, there are some works that are seen as generative graphic design works. They are also seen as information visualization works, and they can also be seen as generative text illustration. This is the work I'm showing now is the work by Artur, Rebelo, and Penousal Machado, graphic narratives, where we have covers that reflect the length of chapters and the number of chapters in a book. Okay, now let's see some of our experiments towards the generative text illustration. I'll describe our first experiments, our first attempt. As I said, we are still working on this subject. We have other students who are working on this subject, but we are going to show you our first experiments. For our first experiments, we worked with short stories, and we are still working with short stories. I think they are ideal for this kind of experiments. In this first attempt, we used the work of the Swiss illustrator Varia Lavater as an artistic reference. Our approach follows a multi-layered representation. It means we have several layers in our illustration. We have been working with the Rita library. I don't know if you are familiar with this library. We use this library for a part of speech tagging. So if you want to tag proper nouns, adjectives, verbs, and so on, we use this library. Then we use lexica to establish. We use some lexica to establish associations between words and emotions, word and color, and the core of this system is the mapping between text properties into visual elements like shape, color, and size. So this is a summary of our first attempt with short stories. Why short stories? And we are still working with short stories. They have a reduced length, no longer than 20,000 words. That's the definition of short story, one of the requirements of short stories. They shouldn't have more than 10,000 words. Single stories usually have a single plot, so it's easier to work with a single plot. And there is a limited number of characters. And sometimes in our experiments we can have, for instance, 10 characters, but then we only choose 3 or 4. So it's good to start with a reduced number of characters. So these properties make short stories ideal to an ideal text for our experiments. As for the artistic reference, I mentioned Varia Lavater. She was a Swiss illustrator. She worked with fairy tales from Jacques Perlot, from Hans Christian Andersen and the Grimm brothers. And her work is known for the use of geometric shapes to represent characters. I'll show you an example of the Little Red Riding Hood. So this is an illustration by Varia Lavater, the Little Red Riding Hood, and you see circles mostly. Okay, there is a U-shaped object. So what do you see here is, okay, you don't see all the elements. No, you don't see in this illustration, you don't see. But Varia Lavater uses circles to represent the mother, the Little Red Riding Hood, the grandmother, the forest. The forest is a collection of circles. The wolf is a black circle. The house, the grandmother's house, is a brown rectangle. The hunter is another circle. So we're talking about people. People are circles, and the bed, the grandmother's bed, is this U-shaped object. So if you look at Varia Lavater's work with fairy tales, what you see is this: folding books with circles representing the characters, mostly circles. And we like this work a lot. This is just an example, but we like this work a lot, and it served as an inspiration for many of the experiments that we have been doing. As for the Rita library, as I said, we use the Rita library to perform a part of speech tagging, which means we detect, or we extract, we classify words. We want to tag names, and then names, we can have proper nouns, we can have, I said names, sorry, nouns. We have nouns, we have proper, nouns can be proper nouns, they can be common nouns. We tag verbs, adjectives, and so on. Regarding emotions, our starting point is the Plutchik's wheel of emotions. Plutchik's wheel of emotions. So we use the series of emotions identified by Plutchik, and then we use 2 lexica, the NRC word emotion association lexicon, to establish an association between words and emotions from the Plutchik's wheel of emotions. And we use another lexicon, the NRC word color association lexicon, which establishes associations between words and colors. So as for the emotions, that's all we have, and I think it's enough to do some work with emotions. So regarding the multi-layered representation, we create 3 layers. The first 3 layers is a layer to represent characters. So we tag proper nouns, and from the proper nouns, we identify characters. The second layer contains common nouns, which can be objects, for instance. And there is a third layer, which is a background, The third layer reflects the sentiment of the story or of the scene. So we have these three layers. I'll describe in detail the first layer, or with a little more detail the first layer. The first layer, each character has a different color. So we use color to distinguish between characters. And we use saturation and geometric distortions to reflect emotions associated with the character. Okay, to be more precise, so we have a color palette. So we have different colors. Each color is associated with a character, but then we have three saturation levels. A positive emotion, or let me put this in other words, more saturation reflects a positive emotion. Less saturation reflects a negative emotion. Neutral emotions are reflected by the level of saturation in the middle. Okay, as I said before, we also use geometric distortions to map emotions. Here we start with our starting point is a circular shape. Then we distort this circular shape. So it can turn into a sharp, irregular shape, a smooth shape. So by doing this, we are able to describe different emotions. Here you can see the examples for emotions: fear, sadness, joy, and anger. So we combine these geometric distortions with the saturation levels to represent emotion. As for the second layer, this idea, we start with this idea of following a collage-based approach, and this idea was used in this first experiment, but we are no longer following this approach. So we look for images on the web, and we use those images to perform the collage. So that's what we use to represent common nouns like objects. If you think of Cinderella, so if you want to represent the shoes, we can use a collage. Finally, the third layer is the background. And the background color reflects the polarity of the sentiment, a positive or negative sentiment. We use warm colors for positive sentiments, whereas negative sentiments are represented with cold colors. So that's the idea. I'm going to present you the whole story, an illustration that for the whole story of Cinderella. As I said, this is preliminary work, and the artifacts must be improved. And you should see the story from left to right, top to bottom. So in the upper left corner, you have the beginning of the story, and on the lower right corner, you have the end of the story. This is a simple example, but here you can see several characters or different emotions, associated with these characters and some objects. So that's where you see the collage. As I said, this is preliminary work, and I'm presenting the whole story. I think it's more interesting to present just a part of the story, but I don't have the code with me, and I couldn't find an image to illustrate that, to show that. To conclude, we believe that generative process bring new possibilities to the field of generative text illustration. Definitely, it's a field to be explored. We are working on this, but I think it's a long journey. But it's the right time because we have powerful tools right now. We have tools that allow us to perform text analysis, tools for generative coding, good resources like the lexica we used. So this is the right time to invest on this kind of research. As for future work, there are many things to do. I'm just enumerating a few that I think are quite important. It's important to address relations between characters. We try that, but it's something that we have to improve. As I said, using collage, I think it wasn't a good idea. At least I don't like the final composition, and we are exploring further semiotics of color and shape in this research, and we want to perform further studies with users, readers of this text, so that we can improve our system. And that's it. Thank you. And if you have questions, I'm here. João is there. Carolina is not here, but I hope we can answer some of the questions that are that deal with the technical details. I don't know if we can answer all of them, but we'll do our best to answer them.
All right, thank you very much for the presentation. And yeah, do we have questions or remarks or comments? I believe there was a nice discussion in the chat right now, so maybe you can...
I have a small comment regarding the final presentation. I think what makes it difficult for me is that you follow, how do you put it, left to right, top to bottom. That creates a break. I feel it would be a lot better if it was just a line, even if it's a convoluted line. And I think you should take the storyline idea to literally in the sense of keeping a line. I was really liking the examples, and this is the first time I see it. But that moment there, you know, it's just a twitch, but it really spoiled it for me because in the yellow brick road, it's no longer a road because it changes line. So you know what I mean?
I totally agree, Penousal. It's I have the same feeling, and we made this remark when we saw this.
Just an idea that really occurred to me. Antonio Cruz, that you know, he is working with lines to represent time series, and he is distorting the lines. So whenever 2 points of the line, in this case it's a time series, whenever you are at the same situation or similar situations, he distorts the line so that the points get closer. that would be very easy to implement here. It would be direct, assuming that you have some sort of similarity metric along different regions of the story. And that would allow you to create a path for the story that would represent the self-similarities of the story, or when two characters meet or whatever. So it would give a structure to your line. And then you could represent it. And I think that would actually work and be quite a cool example, you know?
That's a good idea. Actually, I would like to avoid this, you know, this composition that includes the whole story.
Yeah.
Varia Lavater was doing this, but I think we should avoid it. Okay. But
yeah, maybe. But if you decide to put a storyline, then you have the question of giving a structure to the line. And I believe Antonio Cruz's work could help you on that.
Great.
Just an idea. Okay.
Good idea. Thanks.
Okay, further questions or?
Well, I see here a lot of potential, not only for describing stories or short stories, but short or small blends or conceptual graphs, you know. I think so there's an idea.
Yeah, it's something that we can try and test.
All right, so thank you very much, Pedro. And yeah, I believe we are finished with our presentations for today's workshop, or for the workshop this year. And now I would suggest we move to a closing session, for which I prepared a couple of questions regarding the workshop itself and also the topic of the workshop. So I know, Pedro, if you
sharing, I'll stop sharing.
Sharing your screen here.
Okay.
Okay, thanks. All right, so here are a couple of questions I prepared for the first part. So first of all, as already mentioned in the introduction presentation, it's the first iteration at ICCC, and the question would be if you think it's the right place for such workshop, if there is, I don't know, potential to extend it to the next year. So maybe, I don't know, you think the ICC might be a wrong place for it, and also what was good about this workshop, where the deadline's good, where the submission process is good, what can be improved in communication, for example, what can be improved in organization, I don't know, promotion. So yeah, if you have something to say about this, please.
I have to leave in a few minutes, so I'll start by saying something about the right place or the wrong place. Is this the second time that, or the first?
It's the third time.
Third time.
It's the third time.
Okay. I think I participated as an author. I wasn't there, but I think João went there. It was at ICCBR. Okay. For me, I think ICCC is the right place. It's the right place. And this year we had a record number of submissions, and I think this is a topic that interests a lot of people. So we have computational design in a broad sense. We have this. There's a lot of work on co-creative systems. So I think that this is the right place to present the work, to meet people. And I think if we keep on having this workshop at ICCC, I'm sure this workshop will grow.
Mm-hmm.
Will grow fast.
I guess that's the only problem, that every workshop is working at the same time, and I'm constantly changing and trying to be in all the workshops, and I'm constantly running. So I guess that is the principal problem, because besides that, it's okay.
So how it is during the normal years, so non-corona years? Do you have many sessions in parallel at ICCC? Like, I mean, workshop sessions, are they in parallel, or are they just, I don't know?
I don't know, because it's my first year. But maybe...
Usually they are in parallel also, but to be entirely honest, the fact that we are doing this remotely forced us, well, not forced us, but made us choose a schedule that is tighter, because people are not all in the same time zone. So we need to accommodate different regions. So in normal circumstances, the overlap would be a lot smaller between workshops than it's now, because we could take advantage of the entire morning or the entire afternoon, and now we cannot. So I believe that's something that will be solved naturally in the next ICCC, which hopefully will be, well, it won't be remotely, hopefully. But I would like to reinforce what Pedro said before. I've been in these conferences from the beginning, and in the beginning we did computational creativity workshop in conjunction with ICBR. So we were kind of workshop within case-based reasoning, and eventually we became a conference, and this was already 10 years ago and so on. And I think currently, I have nothing against case-based reasoning. In fact, I start doing research in that area. But I think currently the best place for this workshop, in my opinion, is ICCC. And it would help giving it a more faithful audience, I believe. So I think it would be good for the two events.
Yeah, this is my feeling actually as well, because at ICCBR, I would say, like, not so many people are into case-based design or knowledge-based design or database design. So it's not. It was so the last 2 years were hard to find audience and to gain publication. We had some, but as I said last year, I expanded a little bit to explainable AI. This way we had a couple of publications more, a couple of submissions more. Yeah, but I also believe that ICCC is the best place right now. So second question, I don't know, what did you like, what you didn't like, what we can improve so for the next year probably? Also, if you have something to say about the communication, how was the communication between the organizers and participants? I tried to inform about everything as soon as I could, so I hope it was good.
I think it was good. I mean, I'm a bit biased, right?
Yeah, we are totally biased.
But
you can be critical.
Still, no, the only thing I think is that probably you agree with me. So this workshop is still in the very beginning, but I think it has a lot of potential, and there are a lot of people coming into this computational creativity area related to computational design. And in a way, my opinion is that the computational creativity community at this point still doesn't see the potential of the computational design. And I think this workshop as is here for the best, and it's the way to show this community that we have a place here, because it makes total sense to develop this community. And so I think the way you organized the workshop, and I think you did a great job, was great, but our reach is probably too limited. So if there is something to change is the communities that we can reach, and probably we need to disseminate a bit more and find other people that will be interested for sure, not only in this workshop, but in this community related to the workshop.
I agree. I agree with that as well.
Well, I'm new at this conference, so I'm not really sure. I'm still exploring what this whole conference is about, and I've been here yesterday, and I've been here today. There's a lot of difference in what people are presenting, but I just wanted to say in reply to João that the problem of attracting audiences is not unique to this conference or this workshop. I mean, even in the Gecko workshop where I was, there was a surprisingly a low number of people, and also Evo Star this year, which was held online in Sevilla, which I think both are qualitative, like relatively good workshops and good conferences. And what I heard from people that have been frequenting these conferences for a long time, which I'm also not, I've only been in science for about 3 or 4 years now, is that the talk of getting more audience to specific conferences or workshops, which again I find really good, it's not in the quality, is getting harder and harder. So it might be a problem not of the workshop in itself and about the subjects that it addresses, but maybe there has been a huge increase of workshops, or maybe even, but I'm not really sure, like less scientists relatively in the field. So the problem might lie somewhere else than just in the subjects that you discuss in these conferences or workshops. I'm not really sure, just suggesting.
Just follow up on that, comparing, for instance, with Chico, with EvoStar, even with ICAI, I think ICCC did very well. We have more registrations than in previous years in terms of submissions. I believe you also have, well, I would say record-breaking numbers. So I think it's great for the workshops and even for the entire event. So I'm actually very surprised and very relieved in my case, as you might have guessed, for the community, how well this community has survived and endured this period. And we were fearing the worst in terms of participation and submissions and so on. But it was the exact opposite. So maybe I think it's a very resilient community, and I'm very happy with that.
All right, so let's maybe continue with the second.
One last thing. There might also be a factor of timing involved, Penousal and others. Like last year, for instance, EvoStar and Gecko were very close together and again, I'm new in this field, so but they were really close. The one was in Leipzig in Germany, the other one was in Prague, and they're like literally a stone's throw away. And they were also, so they were geographically close, and they were close, and there was only 3 weeks between them last year, I think, something like that. I'm not really sure. So there might also be a timing element, so that if you time the conference and the workshop is of course attached to the conference. If you time it so that it's geographically and temporally not near a similar conference, and the chances of getting more submissions, I would say, again, in my limited experience, rises a lot.
Yeah, I totally agree with this. In fact, I'm going to pass along these thoughts to the steering committee of ICCC, because I believe September is probably a much better date for ICCC than the traditional dates, because basically the traditional date for me, it collides with everything. It collides with GQ, it collides with CEC, it sometimes kinds of collides with EvoStar. And here in September, I would probably be able to attend every single year, while in the past few years, I ended up sending my students, but I didn't go to ICCC. Well, last year I did go, because it would involve insane travels, which actually I did once, which was coming from Sydney, Australia to Portugal and then to Mexico in a single day to attend ICCC and CEC at the same time. So moving to September, I think it would be great. And even in terms of submissions, it would also be great, for me at least.
Well, but Penousal, are you teaching a lot?
Yeah, unfortunately, yes.
Because like in September, I don't know how it is in other countries, but in the Netherlands, in September kicks off the academic year. It's always like it's a best period here.
Yeah.
In September. Yeah. So my suggestion, but then again, it's up to you guys, would be, because we also have ECTA in November, which might be it's close to EvoStar at least. But my suggestion would be January, which is usually completely empty. Somewhere in the Mediterranean region, we Northern European people love to go there in January.
Well,
and there is a little bit of a latch in teaching just after the Christmas holiday. Maybe that's might be it.
I would definitely pass on these suggestions. I'm not sure what's the exact date, but I'm pretty sure that the traditional dates are not good. So it's almost, for me at least, it's almost the worst possible dates that we usually have.
If it turns out to be January, give me a call, okay?
I will, in the Mediterranean. Okay.
All right, so now let's really move to something else, to the first part.
I have one question, Victor.
Yeah.
So you were the organizers of the first 2 editions of this workshop. So I would like to ask, in your perspective, do you feel that the reception here, do you feel it's better than in the venues that you've done the workshop before? So would you, I mean, I extended you the invitation to come here because I thought it was really great to have this workshop here. And honestly, I hope that this workshop continues to be in ICCC. So this is my feeling.
So yeah, the reception was, let's say, better, and I think it's better, just better fit here as it was before. So yeah. All right, so the second part is basically about the topics of the workshop. I would like to ask, how did you find the selection of the topics? So as I said, in the first 2 years, it was basically more or less case-based design, or with explainable AI. And the second iteration, Also, one question that I know is kind of important for me is if what we do here can have some kind of future in professional creativity. If we can, I don't know, come up with some software idea or something like, I don't know, service which can be of use for professional, because I myself, I also started as a web designer, and this is basically how over different years I came to this research direction, and this would be a kind of important question for me. So maybe you have some ideas on that.
I'm not sure if anyone wants to give their thoughts, but I can. I mean, most of the people that are here from my department, and there are a lot of presentations that came from there, are people that have a background in multimedia design. So they are more or less related with your background. And so to answer your question, I do think, yes, at this point, I think there is the connection between research and work that we do here and that we are presenting is there is a clear gap between what's done in research and what's done in the professional world. But in my opinion, the way is to straighten this gap, right? And trying to show how the things that we produce here can be put to use and can be used in a real life situation. I mean, some of the work presented just before Jéssica, for example, some of the work are applied and are meant to be applied into a real situation. So, so these techniques that we are developing here do have application.
Yes, I totally agree with João, and I think that the way that artificial intelligence is democratized over the web, and you web designer and maybe you understand this. I think especially this kind of systems that have some knowledge that to generate to create new experience to the users and to generate new content and customize the websites. For instance, in this case, in web design, I think will be in the next future very common over the use, very common use over the next years, and I think that the very interesting this workshop, and maybe ECCC is really the best place because a lot of graphic design and these technologies normally are presented at the conference.
Yep. So for me, it was just important that we don't have only this, like, short-term goals to organize a workshop and have papers and have nice submissions and nice workshop, but also something, I don't know, something long-term, which could be our common goal for the next years, for example. So that's why this question came up today. All right, so do you have something else to add to the workshop, to the papers, to the discussion? Okay, so I from my side have to say many thanks to João, who helped all the way from start to the end of the workshop. And I believe if I could issue a creativity or computational creativity medal to João, I would do it, but I can't do it. But so João, that just think of a virtual computational creativity medal for you.
No need. I'm just very happy that the workshop came here. I remember discussing such a workshop with Sérgio is there. So I remember discussing that ICCC needed computational design workshop. So I'm really, really happy that you could take on the invitation. And I know that at some point, due to this COVID situation, we weren't sure if the workshop was going forward or not. We even discussed the possibility of moving it to the next edition. So I'm really glad that you stick to us and that you made this happen. I think it was a lovely workshop with great presentations. And I think we need to continue this on my end. If you need my help next year, count me in. And I think there are a lot of people here that probably would like also to join.
Right, so I'm counting on you then.
And regarding, you are recording the presentations, right? So maybe we can put them out there and maybe do extra dissemination with the works that have been presented here. And this doesn't need to be closed in today's presentations, right? So feel free to send me the videos and we'll disseminate them.
Yeah, I also had an idea to collect presentations and put them on the workshop website, since I'm just not sure if I'm allowed to put papers on the workshop website because of all of the copyright things. So I just thought presentation will be probably easier to put. So I think in the next days I will write a kind of email to from EasyChair to the paper artist to send me the presentation to put on the website. And also
sure, you can send them to me and I will put them on ICCC YouTube channel. Then they'll be there.
Yeah, sounds good. All right, so now the workshop has finished, and I would like to thank you once again for participating, submitting, and discussing. Thanks to ICCC committee for making this possible, and obrigado. I hope I pronounced it correctly. Okay. So yeah.
Dankeschön, Victor.
Thanks.
Dankeschön.
So yeah, that's the official end.
See you soon. You have a tutorial starting now, so you're